Hi, Rafa. It's
Hi,
John.
can you hear me?
I can hear you fine. Is the microphone okay here?
Yes,
Oh,
you're good, and I can let me turn on your video so that you can. Oh, I don't know how to
are,
do that.
are we? Do you want us to keep video on or off until
Uh,
we're
you can keep it off for now, yeah,
okay?
and then in half an hour we'll start the first
Yeah,
panel.
yeah.
Yeah, and we're live in YouTube, and very soon we're going to be live in uh, with the webinar.
Yeah, actually, I have on another computer that has the live part you're actually on right now.
Oh, okay, good to know. Right.
I can see you,
Well,
yeah, on that one.
so in a couple of minutes, we'll get started. Let me
Sure.
see if I'll find the updated program and also post it. Okay, we're going to get started. Good morning, everyone, or good afternoon if you're in Europe, or good evening if you're in Asia, wherever you are in the world. We welcome you. My name is Rafael Yuste. I'm a professor of biological sciences at Columbia. I'm speaking to you from my office. That's my old microscope, and the campus is right behind us. And I also wear two other hats. I'm the director of the Neurotechnology Center at Columbia University, which fosters the development of neurotechnology. And I'm also the chairperson of the Neuro Rights Foundation that works for the research, advocacy, and outreach of neuro rights or human rights approaches to neurotechnology. So the meeting today is about neurotechnology, and we're going to be looking at both the great benefits that it has in store for science and for medicine and for the economy, and we're also going to be discussing the potential risks that it could carry if it were not properly regulated. The meeting is going to have 4 different panels. The first panel will examine neurotechnology. The second panel will examine human rights issues associated with neurotechnology. This is what we call neuro rights, and this will take place back to back in the morning of the Eastern Seaboard in the U.S. And then we'll split for lunch for half an hour, and then we'll have 2 other panels in the afternoon that will explore developments with respect to neuro rights, first in Chile, the Republic of Chile, and then in the UN system. So this is a webinar, and the audience is welcome to send questions through the Q&A. The panelists are generously participating and donating their time. And this is made possible also through generous support of the TCC I Foundation, the Chen Foundation, and also the Neurotechnology Center and the Neuro Rights Foundation. So those are our sponsors for this meeting. So I'm going to actually post in the chat for everyone in the meeting the program, the updated program, and we're going to get started. So I'm going to give you a little bit of an introduction. So first of all, what the hell is neurotechnology? Okay, what are we talking about? So neurotechnology are methods or devices or tools that can be optical, they can be electrical, they can be based on nano science and nanophysics, they can be chemical, they could be acoustical, magnetic, computational. And with this method, you can do two things. You can either record the activity of the nervous system, of neurons in the brain, record the activity of the brain, or you can change the activity of these neurons or these brain circuits. So it's essentially either recording or altering the activity of the brain. So why is neurotechnology important? Why does it matter? Well, it turns out that the brain is not just another organ. It happens to be the organ of the body that generates all of our mental and cognitive abilities. So I'm talking about our thoughts, our memories, our perception, our imagination, our emotions, even your subconscious, the things that you don't know about yourself. All of these things are generated by our brain. Okay. So that neurotechnology enables you to get to the organ that generates the mind, essentially. So that's why it's important. And this is of fundamental importance, at least for three reasons. The first one has to do with science. As you know, we still don't have a general theory of how the brain works. We're making great advances, but we still don't really understand how the brain works. And neurotechnology can enable scientists like ourselves to get in with new tools and explore these brain circuits and decipher what we call the neural code, which is the code by which the activity of neurons generate, for example, behavior or mental activity. Just as if it were a foreign language, we can finally have the tools to tap into these conversations of these neurons and decipher this code. The second reason why neurotechnology is important has to do with the clinic. As you know from personal experiences with family members or friends, brain diseases have very poor prognosis, and essentially they have no cure. I'm talking about diseases that could be neurological, or they could be mental diseases, from Alzheimer's to schizophrenia.
Right?
I think someone has to mute themselves. Can you all mute yourself, please? You don't mind? Yeah. So this is like, I think, Jamie, that might have been you. Alzheimer's, schizophrenia, Parkinson's, mental handicap, paralysis, ALS. I mean, these are terrible diseases. Anxiety, depression, bipolar disease. This is the dark corner of medicine, in spite of the heroic efforts of our colleagues in psychiatry and neurology. And the reason is because it's very hard to fix the organ, what we call the pathophysiology of the system. If you don't understand the pathophysiology, you're not going to be able to cure the problem. And that's why it's urgent that we develop these new technologies for the patients. And we're going to talk about that later this morning. We're going to meet one patient neurotechnology. And then the third reason why neurotechnology is important has to do with the economy, because it's very likely that, for sure, that brains, not just of humans, but of all animals, are computing using very sophisticated algorithms. And if we can only understand how those algorithms work, for sure we'll revolutionize our current tech industry and the computer industry, because if you just do the numbers, the brain of a person just roughly has about 3 times more connections than the entire internet of the earth. No? So, and we power this with just with the equivalent of about a 20-watt bulb, light bulb. So nature knows something that we don't know. So that's why many companies and governments are very excited about neurotechnology, because they think this is going to be like a next industrial revolution. And in fact, this brings me to the question, why is neurotechnology important today? Why are we talking about it now and not 10 years ago or 10 years from now? Well, and this has to do with this perception of the economic potential for neurotechnology, then together with the arguments that I just made to you about its importance for science and for medicine, led President Obama to launch the US Brain Initiative in 2013. And he compared this launching of the US Brain Initiative to the project Sending a Man to the Moon. The US Brain Initiative is a large-scale project that will last 12 years and involves currently about 550 laboratories around the country and the world. And is funded, this year's budget is close to $1 billion, so $900 million. So this is a massive scale project. This is the largest neuroscience project in history. And the purpose of this US Brain Initiative is to develop neurotechnology. So this is what it's about, developing methods, again, to record and activate neural circuits, again, for scientific reasons, medical reasons, economic reasons. The US Brain Initiative has also stimulated the generation of similar brain initiatives in other countries, including China, Japan, South Korea, Australia, Canada, Israel, and the European Union launched a similar project more or less at the same time in 2013, the Human Brain Project. So we're talking about a worldwide consortium of national projects that have been all harnessed together through the creation of the International Brain Initiative. So this is similar to what happened with the Human Genome Project. No? So this is fantastic. Now we have not just the US, but the entire world is developing these methods, and this could lead to a revolution in the economy, as President Obama argued, a revolution for medicine, no, for the clinic, and also a revolution for science. And again, I cannot have to underscore the importance of understanding how the brain works, because the brain is really what makes us human. So this is going to be the first time, if we understood how the brain works, how it generates our mind, we'll understand ourselves as human beings from the inside for the first time. So this is going to be a historic moment. I compare this sometimes to a new renaissance. And this could happen led by this development of methods. Now, without developing methods, we're just not going to stumble into how the brain works. I think at this point, many of us are convinced that we really need to bring new methods to the table. So I just quickly, I told you that neurotechnologies are all these devices, all these tools that are getting developed. They come in 2 flavors. There's some that are invasive, which means that they require neurosurgery. And neurosurgeon has to insert the device inside your brain. Deep brain stimulation is an example. Some of the brain-computer interfaces that you're going to hear about are another example. And then some are non-invasive that look like a helmet, like a diadem, like these earphones that I'm wearing, and they interface with the brain, but without the need of surgery. So those are, there are many companies that are selling them, like EEG devices, and MEG is another example, functional magnetic resonance. We're going to hear about this in the future. And these are things you can use in humans, but of course, animal experiments have been going on for a long time. And in the labs, working with animals, like in my own lab here at Columbia using mice, we can use invasive optical neurotechnology with 2-photon lasers to do holographic imaging and manipulation of brain circuits, to the point that, just to give you a feeling for the flavor of the power of neurotechnology, that we can decode the visual cortex of a mouse while the mouse is looking at a screen, and we can find out what the mouse is looking at, okay? And then we can also, with other lasers, we can actually implant into its brain the patterns of activity that correspond to an image, and the mouse behaves as if it were looking at this image. So in other words, we can artificially implant images into the brain of a mouse and change the behavior of the mouse. So this shows you the power of neurotechnology in animal experiments, and it's likely that whatever you can do in an animal today, you will be able to do in a human tomorrow. So this is the reason why it's important to start discussing issues that have to do with the ethics and societal aspects of neurotechnology, in spite of the fact that we're all bullish about developing it, if nothing else, just for understanding the brain and for the patients. So this also gives you a feeling that technologies are neutral. You can use them for to great benefit, but they also have associated risks. And it's a lesson we learned the hard way. Right behind me, right behind this window, is the old Pupin Hall at Columbia University, which is the National Registry of Historic Places, because in the basement of Pupin Hall, they built the first atomic reactor in history. And the physicists that built it are the physicists that started the Manhattan Project, which is the creation of the atomic bomb. And that's why it was called Manhattan, because it started right here in the island of Manhattan. But the physicists that created these weapons of mass destruction were the first ones to argue for the international global regulation of atomic energy. And through their lobbying, the Atomic Energy Commission was created by the UN, and it's been handling the development of atomic energy for both military and non-military use ever since. No, so this is just a classical example how technology is neutral, and this is the same with neurotechnology. It has great benefits, but there are also some risks and perils that we have to look at it, particularly now before neurotechnology really flourishes with all these different projects. And this is a little bit the purpose of the meeting. Let's look at both the great benefits and risks of neurotechnology, and let's discuss what we could do to ensure that this new revolution comes into society with the strongest benefits and minimal risk. And this argument was made beautifully recently by a movie from the German director Werner Herzog. The movie is called The Theater of Thought. It's just been premiered at the Toronto Film Festival, and it was premiered last week here in New York at the Documentary Film Festival. And it turns out that a lot of the panelists that you're going to hear today are participating in this movie. They were interviewed by Werner. So you're going to see some of the panelists, and we're going to show you some clips of the movie that touch on these issues, the importance of neurotechnology, how it can help patients, how it can be used in animal experiments to change the behavior of an animal, control the behavior of the animal, and also discuss some of the ethical issues associated with it. So with this introduction, if we can just go for the next 50 minutes, we're going to see a few excerpts, a few clips from the Herzog movie. And after that, we'll just jump into the first panel. So Lex, could you first start playing the clips from the movie? Maybe start with the clip from Jamie or the dice roll, either one of them. I will let you know if things don't work.
Back to science. At Stanford, we met Carl Dicer-Roth. He is the main inventor of a method to optically activate neurons in animals and control their behavior. You are encoding animals, you are encoding mice. How do you do that?
We use light in a way that's opposite to how people usually think about the use of light. When we think about light, we think about collecting information from something. But what we've developed is a way to flip that around. We send light in, and we use light to control things inside brains, and we call this optogenetics.
But you have revolutionized the whole field of science with this method, haven't you?
Well, it's given us a new capability that we never had before, and it was a very important one. It allowed us to see what really matters for function. It allowed us to see if you add or take away the firing of neurons in the brain in specific cells, not any cells, one type or another type, or one collection or another collection, you get to see what actually matters for all the mysteries of the brain: action, cognition, sensation, or all of them together.
And why mice?
We use mice, we use rats, we use fish. These are our cousins. These are vertebrates. They have many of the same brain structures we have. It's scaled up vastly in our lineage, but these are our relatives, and they have ancestral and highly conserved structures. And by studying them, we can understand ourselves.
And you are encoding mice with what kind of codes? What do you tell them? What do you want to see?
Well, this has been one of the most remarkable features of optogenetics, is we're finding that we can take an animal and we can turn up or down almost anything about its behavior, very complex patterns of action. We can make an animal more or less aggressive or nurturing or defensive, hungry, thirsty, sleepy, more or less motivated, all these things that are very important to how we think about our priorities, our inclinations, our drives. It was in the summer of 2007, so just about 14 years ago exactly. And I had a brilliant student named Feng Zhang in the laboratory, and what he did was he put a gene from algae, a light-activated ion channel, and this is ion movement through a channel. This is how our neurons work. Normally they're not light-activated, which is why we had to get a light-activated gene from algae. When we did that, and we put that into the brain of a mouse, and we delivered through a fiber optic light to stimulate those neurons that we had targeted, we saw the animal immediately start to move, to start to circle to the left. We had put this fiber optic into the right part of the brain. As you know, the right part of the brain controls movement toward the left side of the world. And we saw this animal start to circle left immediately as soon as we turned on the light. And when we turned it off, it stopped immediately. Just last year, at the end of 2020, we did an experiment where we used a special virus effectively into the bloodstream, not a direct injection into the brain. So nothing physically entered the brain at all. And we used an extremely sensitive opsin, very light-sensitive opsin, so we could deliver light from outside the brain itself. Those two together allowed us to, without ever entering the brain at all, to make mice more social. And so that was an interesting experiment. It shows how far things have come from those early days, and it does point the way to interesting developments in the future.
Could it be that we all live in some sort of constructed fantasy world?
You know, this is an interesting question. The Spanish writer Miguel de Unamuno actually used to speculate on this, and he thought that what we think is real, is really real, is not, that it's all irrational ultimately, and we construct a fake reality around ourselves to protect ourselves from the irrational that is real. And you know, I can't argue with that.
So this was Carl Dijsselhoff from Stanford, and now maybe if we could watch the clip that the interview with Jamie Davis, that would be fantastic, Lux. Oh, so yeah, let's play John Donoghue then. Yes. So John, you're going to watch your interview, I think, probably for the first time since the movie hasn't been released. So I hope you like it. I thought it came out great.
Thanks.
John Donahue is the one who took the next step. He's involved into the most advanced patient studies using brain-computer interfaces. The spectrum of brain ailments is vast.
There are literally more than 1 billion people that are affected by diseases of their brain or their nervous system or their peripheral nerves. And most of them today are treated with drugs, but some of them are now being treated with neurotechnology. For example, in impaired vision, there are implants that are being developed and even available that can help people see again. And now a disorder, a big contrast is schizophrenia, which is a thought disorder. People hear voices and have disordered thought. There's really almost nothing to treat there, so that's really at the forefront.
Depression.
Depression affects very large numbers of people worldwide. Maybe 1 in every 5 people have some depression in their life. And we're now beginning to use deep brain stimulation, electrical stimulation techniques to help people with severe depression.
Chronic pain.
Chronic pain, there are devices today that can be implanted in the spinal cord in the back. And since the pain comes in from the body, a stimulation in the back will actually stop the pain from coming in, stop the information from coming in, and people don't feel pain. This is a big success. A lot of people have pain stimulators. This is a big successful application of technology today.
One of the most striking successes has been Parkinson's disease. On the right, we see a patient after a device has been implanted directly into his brain. He walks almost normally. On the left, we see him with the device switched off.
So this is one of the patients that we implanted with the same kind of array technology. She was paralyzed for more than a decade from a stroke and unable to do anything from the neck down. She can't move her arms, she can't do anything. And she is controlling this robot arm only using the thoughts that are being detected and transmitted outside through this connector on her head to computers. And you can see how happy she is that she is controlling this for the first time. She's able to interact with the world.
Wonderful. So this was the interview with John Donahue. And now if we could see the interview with Sarah Goering, who's another of our panelists in the first panel, that would be great.
We met Sarah Goering, an expert in free will and bioethics. Professor Goering, as a philosopher, you're confronted with the incredible advances in neurotechnology, neurosciences. What are the new questions?
Oh, there are so many new questions.
Go into the most burning ones.
The most burning new questions, I would say, especially when we talk about implanted neural devices, there are real questions around how we are as human agents in the world. And by that, I mean people who can enact our intentions on the world. And the internal private space seems really important and challenged by some of the
thoughts, our thoughts, the privacy, the autonomy of our thoughts.
That's right. So it's both access to them, but then control over them. So some of the devices are recording from the brain to drive something else outside of us, a cursor or a robotic arm. But other ones are about stimulating areas of the brain, hopefully to help us in particular ways. They can be used therapeutically, as treatment, but also sometimes to try to bring about certain behavioral changes. And that seems like a kind of potential for manipulation that's very worrisome. It could be putting an idea, a particular kind of word into your head. And you can think about the ways that advertisers would be delighted with that opportunity. If I have something like the kind of device that various companies are interested in making that can read out from my neural activity to help me surf the internet or type something, right? If it's a two-way channel and it can come back in too, then there might be ways that they can put ideas for what I should be buying, as they do with ads at the side of my screen, but now directly into my brain.
And what if we had some implants in us already? You included?
So do I know that I don't have an implant in me?
Would you know?
Descartes would say, I do not know that for certain. The question is, would I know or could I know for sure? I think, I mean, if they're good functioning ones, possibly not. I feel worried about saying that because I don't want to feed the rumors that we know are out there for seriously mentally ill people who do have this belief. But I will say this, at least to get a neural device now, right, especially an implantable one requires a brain surgery, you're going to know, right, if that kind of thing is happening. You'll have some awareness of that.
Wonderful. So thank you, Lux, for showing these clips of the Herzog movie. Again, the movie is called The Theater of Thought, and as soon as it's released by Studio, you should be able to watch it and stream it wherever you are in the world. But this brings us to our first panel. The first panel is going to focus on neurotechnology. We're going to be discussing neurotechnology for 1 hour, and the panelists are Jamie Davis, if you could turn on your camera, and John Donahue and Sarah Goering that you just met in the movies. So if you could allow Alexa, Jamie, Sarah, and John to turn on their cameras and mute themselves so that we can all be participating in this panel together. And I'm going to be moderating the panel. But I just don't see any of my panelists. Let me see if I can. John, can you hear me? And
I can
Sarah,
hear you. I can't start my video.
Okay, so we'll work on that. And Sarah, can you hear us too?
I'm the same way, by the way. You just need to let me start my video.
Yep.
Okay.
Also me.
All right. So while we're starting your videos, let me briefly introduce the three panelists. So first, let me start with Jamie. I'll just say a few words about each of you. So Jamie Davis wears many hats. He's co-founder and managing partner of Everyone Inc., which is a venture studio that invests in companies, tech companies. And he's also the founding team member and board member of the Center for New Data, which is a nonprofit to make information available to researchers and societies in general. And he also is co-founder of the Neuro Rights Foundation. But on top of that, he's a former neurotechnology patient. So as we're going to hear his story, I wish we could have played the clip of his interview with Werner, but we'll talk to him about it. The other two panelists, John Donahue, who you just watched in the clip, he's a professor neuroscience at Brown University. He's an expert in neurotechnology, expert in brain-computer interfaces, and he led some of the most pioneering efforts in this respect. And the patient work that you just saw came from his group. And Sarah Goering, who joins us from the University of Washington, Seattle. And thank you, Sarah, for getting up so early. I really apologize to make you start your day that early for us. She's a philosopher. She happens to be the chair of philosophy at UW now, so I know she's super busy. And she's here today with us because she's one of the experts in the world in agency, and she's very interested and very thoughtful about the ethical and societal impact of neurotechnology. So, so with this introduction, let's start with Jamie. So, Jamie, welcome. So we didn't get to hear your story as a patient, which is a perspective that I think should be the first ones to consider when we discuss neurotechnology in this meeting today. So can you tell us about what happened to you and how can you just fill us in your own personal story? And thank you for sharing with the audience. Yeah.
Yeah, thank you so much. I'll just go very briefly. In my own experience, I've had 2 neurosurgeries. The first was as a result, I have acromegaly, which is gigantism, which causes you to grow larger. It proceeds in people very differently, so it did not manifest in a way that was really picked up by me or my doctors. There was early tests also that proved inconclusive, but I did have transsphenoidal surgery where you go up through your nose and have lasers to remove a pituitary tumor, and it is now controlled with medication. Second, I was in an accident where I had a bruise on my spinal cord where I was actually paralyzed from the neck down. And luckily, I have not returned to full function, but I was able to be able to walk again as part of that experience. So I'm somebody who would directly benefit from neurotechnology. I could have benefited earlier from imaging work, right? Which just would have actually had it, it was very obvious once I had the image work, it could have been seen. There's other ways where that could have been tested, but that was the most definitive conclusion. And there has been conversation, of course, about people doing regular image work of their brain for a variety of purposes. So there's the idea of early identification and testing and how that works. The second is obviously I would be a beneficiary from neurotechnology to help me return to full function. And obviously I was at a spinal cord ward. My uncle was a quadriplegic because of a football injury. So this has been something that's been very present to me in my entire life. And so in our film and in our general work, one side of the house we're focused in, obviously, on both advancing neurotechnology in ways that ensure its ethical uses that Sarah spoke to in the film and others. The other side of the house is around equity, which is making sure that we commercialize and advance it so it gets in the hands of more people faster. So I'm somebody who cares about both of those things on that side, in part because I would be a personal beneficiary of it. And I think that's something that's very present in our current conversation, right? Which is how do we balance the interests of ethics and in equity as we think about that. Final note, the equity questions go to how we actually regulate it, in what agency regulates it, number one, and then number two, also thinking about how it will be covered in the American health context by insurance and other things. So with any new capability, there's obviously significant questions, not only about its efficacy, but ultimately about access and affordability as well. And so I think that'll be something that we'll touch on even more, what will be covered, what won't be covered, et cetera. So I'll stop there and can speak more later. Thank you so much, Rafa.
So Jamie, you were completely paralyzed, just like this woman that we just saw in the clip, no? And,
yes, I was. Yeah.
They had to intubate you too, no?
They did
at the beginning, no, too, because you couldn't even breathe. So you would have been an immediate beneficiary of like a brain-computer interface, for example. Was that ever discussed when you were in the hospital? Was that
not to my knowledge, Rafa? It was. And I was again, because I had a family member who was a quadriplegic. This was something that I was familiar with, but it was not discussed in any meaningful way. Stem cells were discussed more in my situation, or something regenerative in that way, as opposed to anything related to BCI.
Yeah, and you were lucky that it was a bruise. It wasn't a fracture or a hemisection or a section of your spinal cord. So eventually you recover. Now, how long did it take you for you to?
I was in a spinal cord ward after I had a surgery a couple months in the spinal cord ward, and I was walking on a walker, still in a wheelchair. And it was really a few months until the bruise healed enough until I was able to sort of walk independently with a cane.
Yeah, and was this all with private insurance, or with was that like
private insurance? But as anyone here in the American health system would know, there was a lot of things not covered as part of that. So, and that is something that I know from being in, a spinal cord ward. That's something that we need to think about, more and more.
Because I mean,
So
these technologies are not inexpensive, and
correct.
the brain-computer interface can make a huge difference in the life of a person if you're tetraplegic or if you're paralyzed. No, so
100%.
this is something that has to be. So Jamie, just one last question before we move to John. So I know you wear many hats now, but if you just go back to your hat as a patient, and I mean you've been lucky, but what would be the dream of your dream as a former patient for the development of neurotechnology in the future? Now, what
well, because I've had these two experiences, one in measurement and prevention, right? So the idea of like how it can unlock a direct medical and then obviously health and eventually wellness benefits on the front side. So, and I'm somebody who with early detection of that, it would have mattered a lot because I was not fully diagnosed and did not have treatment for my acromegaly really into my late 20s or around 30 years old. And it had an impact on my life and continues to have an impact on my life for that.
So that would have helped if they had caught it.
100%.
Right away.
I live with those health impacts of the fact that it went so long in an uncontrolled way. The second is obviously, because of the accident that I had, is making sure that there's both, that those approaches are both developed, but also the access and affordability, of these. And I'm really concerned that we're going to end up in a two-part kind of medical health wellness system where those that have access and can afford it get one type of set of treatments and others do not.
That neurotechnology will be only for the ones for the rich, for the people parts of society or countries that can afford it. Not
third, and I see this in my work in technology and before, we obviously know there's a lot of people who are able to access things outside of the normal medical or health practice and are now doing this for performance, productivity, and other things. So that's something also that I keep an eye out on as well. And so, and how that will develop in its own space, separate from like direct medical coverage, et cetera, I think will be important.
Thank you, Jimmy. So we'll get back to you, but let's talk now with John. So John, I didn't do justice to your CV. You were at some point also the head of the exciting center in Geneva, the Vice Center, which is one of the world-leading centers for development of neurotechnology. Came back to the U.S. You've been also engaged in the Origin of the Brain initiative. I'm a witness to that. Your critical influences in convincing the White House, NIH, and NSF to develop neurotechnology. So, and you've been at this game of brain-computer interfaces from the very beginning. So I just wanted to hear your thoughts about neurotechnology, particularly with respect to the clinical applications and the state of neurotechnology, the future. So, what are your thoughts? And you're welcome also to share slides or presentations.
Yeah, I'd like to spend about a little less than 10 minutes and just show some slides. Just to describe the current status of implanted brain interfaces and particularly brain-computer interfaces, or BCIs, BMIs, or machine interfaces, they're called.
Yeah. By the way, I have to correct something, and this is in reference in response to Sarah's input that I shouldn't have used the word invasive and non-invasive. Implanted and non-implantable, because you could argue that things that are non-invasive could still be invasive.
Right. I think that we want to be very careful. It's a particular bug I have. I think that we want to say that things that are outside. Carl just talked about something in the video clip about how he was influencing the brain with light on the outside. I would consider that quite invasive. So I think that we want to be careful in the way we use words. I'd like to show some slides. So if I could, can I share the
Yeah.
screen? Let's see if I can do
I
that.
think you are co-host. You should be able to share the screen.
Yeah.
Yes, it's
There we
working
go.
out now, and you can just put them in full presentation mode.
I think that's
it. It's perfect. You can take it from here. Yeah.
good. So I'm going to talk about these devices that can read brain activity, and I'll mention the medical applications and something about what limits their capabilities. And then I'd like to provide an intuitive sense for something, I think, for the general public to get a sense of how well we can read out meaning of brain signals. And I think this will help to set the agenda of where we can go wrong ethically if we know what we can do now and what we can't do. And and figure out, we can get a better sense of what you can learn about your private internal thinking from the the signals that are there. So this is the video. You actually saw this briefly in the clip in the Herzog movie. It's from 2012, 10 years ago. We actually started with the first humans now 20 years ago. And this is part of an ongoing project called BrainGate. And this is Kathy Hutchinson using her own brain activity to control a robot arm to take a drink. So she was paralyzed with a stroke, a really massive stroke that left her unable to speak or usefully control her arms or her legs. And we implanted this sort of aspirin-sized microelectrode sensor into her motor cortex, which is an important spots where commands for movement of your body parts are generated. So the array's hair-sized probes that you'll get to see in a couple of seconds pick up minute electrical impulses from about 100 neurons. And those are amplified in the box that you can see connected on her head. And then it's fed through a wire to a computer that can decode the patterns of activity, the patterns of neural impulses into signals like go up, down, left, right, open or close the hand. And as you can see, she can control the arm, she can reach out, she can pick up the bottle, and she can take a drink, this was actually the first time she'd ever done anything like this for, I think, more than, I think this hit point was 10 years in her life. This was where we were 10 years ago, and this approach has been used by people with paralysis to control computer cursors, or to type, or on a virtual keyboard, or to use a computer for everything that you can do with a computer, or even to activate their own muscles through implanted stimulators, so that a person who was paralyzed actually picked up a drink with his own paralyzed arm and was able to eat and drink using that in a demonstration. These are not products. So the BCI field is now getting ready to create commercial devices. That's about where we are today, to replace lost functions and even do things like encourage repair of the nervous system. But not, as I said, nothing is approved yet. There's also a lot of non-medical application ideas that are floating around to give able-bodied people the ability to communicate with machines directly from their brain, or to other brains, brain-to-brain communication, or even more wildly, to me anyway, to control add-on mechanical body parts or have potential applications. These are all potential, kind of interesting applications that have a kind of value or implications that we should really talk about and debate. Now, you might ask, why is Kathy's control so slow and cumbersome? And there's really a series of challenges, engineering, clinical, and neuroscience, that all affect performance. That is what we can read out, what we can do. So one problem is the interface with the brain. It undersamples, which means it doesn't get everything that's going on. In fact, it gets a very small amount. But it's kind of like, one analogy is like reading a book with half the words missing or half the pages of the book gone. The microelectrodes we put in the brain resolve electrical impulses, this communication code of neurons, but they sample maybe 100 out of the millions involved in movement or speech. Neural interfaces can also be placed on top of the brain. They're called ECOG grids, which consists of dozens to hundreds of collar button sized discs that are in a plastic sheet and laid on top of the brain by a surgeon. They can only pick up averaged activity of thousands of neurons at a time. They lack single neuron precision of the implanted electrode. So it's kind of like the ECOG, or the surface grids, are kind of like listening to the roar of the crowd rather than listening in on a specific conversation on your phone. A further challenge with all of this is developing the electronics that can process so much of this information. And we're getting to the point where there are technologies coming on where we can increase the numbers of cells that we pick up from tens to hundreds of times more. But we need electronics, we need devices that are really challenging in engineering, like they have to fit into small spaces. They use little power, they don't leak, they have powerful radios that can get rid of the wires and transmit large amounts of information. All of this is possible, but it's still being developed. And the third and biggest problem that I'll spend a bit of time on here is decoding or interpreting the language of the brain. And I use this analogy of this kind of funny QR code on the brain. QR codes, they have a kind of a limited but intuitively useful analogy to understand brain coding. So patterns of neural activity related to any particular thought are like the entire brain generating QR codes across a number of areas. So that's really what's going on in your brain now. Lots of activity patterns being generated. Today, we either try to sample one region with precision, like motor cortex and Kathy, or using a microelectrode array, or lots of regions using these surface grids, which kind of give us blurry versions of these patterns. In reality, the patterns are changing 20 times a second, but I won't talk about that for this analogy. So let me give you a sense of this decoding. So as I just mentioned, brain activity is like making sense of a QR code. When you look at it, it looks meaningless, but if you have your smartphone and with a reader on it, you can extract the pattern's meaning. So for the nervous system, we have to actually build our decoder ourselves. We ask a person to do this, we ask a person to think about doing something like writing the letter A. And when they imagine writing the letter A, it generates a pattern in the brain. We sample that activity pattern and store it. Then when in the future, if the person thinks about making the letter A and that pattern is generated, so whenever we see that pattern, we now decode it and say that person is trying to generate the letter A. So using very rough estimates to give you a sense of what we can do and a lot of very loose assumptions, the pattern seen in 100 neural channels can code maybe 1,000 different items. So if we wanted, for example, to build a decoder of all of the 100,000 syllables in the English language, we probably would need 100 arrays or a surface ECOG grid with something like 700 sites. So putting all of those sensors onto or into the brain would be a big surgical challenge. I just made a little map of like what would it look like to cover the brain with 100 arrays or a grid that would cover a very large part of the brain. These are really surgical challenges, and it would be big electronics challenges to get all that information into a computer. In addition, the code for exactly what you're thinking, say if you think in syllables, would require sampling almost every neuron. And so I expect that reading your exact thoughts in real time is not going to happen with technology that we can foresee right now. But we can, even today, provide important clinical benefit by decoding even with these limited samples, like we can restore movement or we can able to restore the ability to communicate, as I'll show you here. So the movie you're seeing is a recent experiment from Krishna Shenoy's group, which is part of the current BrainGates consortium, which they built a decoding model for a person with paralysis and by recording the pattern produced in the motor cortex when the person imagined writing each letter of the alphabet. So they captured the pattern that represented each letter. And that pattern was unique enough that they could decode the activity while they imagined writing each letter with their hand. And you can see that the decoded letters are coming out below. And he's typing pretty close to typical typing rates. In the experiment, they got up to 90 characters per minute, which is kind of like what you or I would do. In addition, Eddie Chang's group at University of California, San Francisco, just this year showed that you can get about a third as good as spelling rate using the coarse symbols of these ECOG grids placed on the top of the brain. Compared to just using precision recording in one spot. So both of these ways can give us information about aspects of your thought. In this case, as long as your thoughts are spelled out in words one at a time, one letter at a time. But now we want to say, what about reading out much more abstract concepts like cheeseburgers, which don't really have a clear motor correlate? What pattern represents a cheeseburger and all its derivations? I suspect we don't have to worry about we don't have enough samples to build a library of patterns that represent burger-related concepts. So I think, mind reading your next fast food purchase is far beyond reach for some time. However, we can read out successions of letters or intended movements, as you've seen in the two movies. And we can get better with more samples, meaning brain decoding will improve, giving us more insight into your thoughts. Better BCI interfaces, better electronics, and better decoding is going to improve our ability to restore movements or to allow efficient communication for those who have lost speech. And I predict that we're going to see large groups of BCI users within 10 years. I also think we're going to see BCIs that can predict or prevent or treat atypical brain states, like those that lead up to a seizure, which actually there's already a kind of device like this, or that those that can read out brain patterns related to unwanted movements or personality or mood changes. And all of these applications, of course, have social, legal, and ethical implications concerning our access, privacy, and our personal identity that should be part of our discussions today and on into the future. So thanks. I hope that gives you a sense of sort of what we can do today and what kind of information we can read out and what the possibilities are for the future.
Thank you, John. So this sets the stage perfectly for Sarah. So Sarah, I also didn't do justice to your accomplishments. I know you don't like to be in the limelight, but I do have to tell people that through your efforts, the University of Washington, Seattle, it's one of the bright spots in the map in the world for neuroethics. And I know you've been thinking about this for a long time. So what are your thoughts in respect to the way that neurotechnology is progressing? We can touch in a discussion among all of us later more on what's getting developed in the non-intrusive or non-implantable methods, but what are sort of your thoughts right out of the gate with respect to neurotechnology as a professional philosopher, as an ethicist, someone who cares about these humanistic parts? Yeah.
Thanks, Rafa, for the invitation to come. And yeah, that was a little frightening seeing the clip from Herzog's film. I hadn't seen that either. You always wonder
you came out great.
What will it look like?
You have the talent for the screen, I say.
So I just want to say one of the things that I do here at UW is work with the UW Center for Neurotechnology as an ethicist and with a research group they're mainly coming from the discipline of philosophy, but with interest in law and clinical psychology and others working together to think through these ethics issues related to neurotechnology. And jumping off from what John said, I think there's both a kind of immediate concern of where the technology is that we want to be very aware of and actively involved in thinking through those ethics issues. And then it's also important to kind of do horizon scanning and forecast where we may be going so that we put some regulations in place so that we're thinking through potential endpoints and the ways that we protect against some of the harms that could come from this kind of technology. And as Rafa has said, and John and Jamie made really clear, there's so many benefits that can arise from having this kind of understanding of the brain and access to it. I just think we need to be thinking at the same time about opening up those new portals to the brain and the way, both for recording out and then for stimulating in or altering something in the activity of the brain, for how that affects how we are in the world individually. So I think our group's main interest has been in agency and how that's affected, right? If you think about a paradigmatic sense of agency, it's that I have an intention and I enact it on the world in some way. And the participant in the BrainGate study that John showed is able to do that using this amazing technology to control something external to her. It's, in that case, a slow inaction, right? But she is able to bring the thermos up to her mouth and take a drink. And so she's impacting the world through what's happening in her brain. We have lots of intentions that we don't act on, right? Or longer term intentions or considered intentions. And when you think about a device that's able to decode, even if it's not able to decode with great precision, as John said very clearly, if we have good enough decoding that we can do some inference and take an action, right? Then the worry is about privacy and what is opened up to the world that would otherwise be contained within my own private sphere. I think there are lots of, for the purpose of intimacy, we open ourselves up and share things that are private. Typically, we have control over what we're sharing, even if our bodies sometimes give off signals of things that we would prefer to keep private. I sweat or I shake or I flush or something like that. I think one of the concerns here is that the device that's intended to help me enact my intention on the world might also then gather or glean certain other things from my private spaces that I prefer not to share. And again, even if it's imperfect in terms of the decoding, if we can infer from the available data, then we can make best guesses about what is happening there. I think part of agency is thinking about responsibility for action. Part of it is thinking about a sense of authenticity. Is this thing that's happening really me and the way I understand myself? When we look at some of the studies of deep brain stimulation, people do really well, say for Parkinson's, but there are people who find themselves behaving somewhat differently, more impulsively. It might be difficult to know whether that's entirely from the device or from the progression of the disorder, but they will feel insecure about whether or not they have responsibility for the behaviors that are following. And, this is stuff that we have heard talking with users of devices, even the very, contemporary devices. So we're not now thinking to where this may be going in the future. So I think we want to pay attention to preserving, because I think it's very important for us in our sense of acting in the world to preserve that sense of agency and responsibility. And I guess the last thing I would add in there, based on what Rafa said about his own lab and then what Carl said in the video clip, is I think maybe this is the wrong political moment to say that we try to trust the sensory impressions that we get from the world, because we have a lot of misinformation out there. But the very basic expectation that the inputs that I'm receiving that really build the sensory world that I believe is there around me, now we can alter those as well, right? And so there's this chance, as with Rafa's mice, to alter what an individual believes they are seeing in the world or believes they are hearing in the world. And that's just an incredible power. It can be used so well, right, to allow people to gain back function that they had before, but it could also be misdirected in troubling ways. And so I think we want to think very carefully about things like mental privacy and mental integrity, which we'll probably talk about more in the session on human rights, and how we put things in place now, not to clamp down on the incredible and valuable innovation, but to just offer some protections given this new access to the brain, which, as Rafa says, is a very central organ for how we understand ourselves and think about who we are. I think I'll stop there.
Thank you, Sarah. So you've touched on the potential impact of neurotechnology on mental privacy and on agency or sense of identity. So one thing I wanted to ask you is with respect to mental augmentation. So you could argue that the ability to connect the brain directly through a brain-computer interface is either implantable or non-implantable. Sooner or later will allow humans to use external information to enhance ourselves, our own cognitive abilities, or vice versa, to just use our own mental activity to enhance our lives and enhance our maybe through avatars or robotic arms, as you've seen, our own physical state, and even be able to control some avatar that is not even where we're present. So this is going to completely change the game of humanity as we know it. No, and this is in the future, but you could argue that the writing's in the wall. This will happen at some point because humans have always used any technology to enhance our own ourselves. No? So how does a philosopher like you look at this issue of mental augmentation and the impact it would have on the nature of a human being? No?
Yeah, I mean, I think it's potentially a radical impact because we can be altering the very way that we interact with the world, what kind of sensory capacity, there are so many wider options out there. I do think, I mean, the concerns about enhancement are not unique to neurotechnology, but I think we have to pay close attention first to whether or not the things that we take to be enhancing or augmenting are in fact likely to bring the benefit that we're expecting from that. So just one kind of example is I think understandably many people are interested in neurotechnology for memory disorders and thinking about dementia treatment. And no one is going to say it's a great thing. We shouldn't pay attention to that sort of issue, which is such a widespread one around the world and with an aging population. But I do think we want to know that the kind of stimulation that is provided and the effect that it has is, targeted in the right way, because there are things that it's very beneficial for us to be able to forget or not dwell on. And I don't know that we have that level of control. And so I think we want to pay good attention to both the benefits we seek through kind of enhancements, but then also the negative sides that we may be less aware of heading into it in order to try to head those off. If we do find things that are, incredibly beneficial, which I'm totally open to, then I think I would go back to Jamie's point that we really have to think carefully about equity around access to those things. Because the way that we perform and make money in a capitalist society is often based on our cognition and our speed of cognition, another rate. And if that's something that can be amplified and, enhanced in ways for people who can afford it, then you could imagine really significant disparities being created, more so than what we are already experiencing.
Is it too early to discuss these issues, or you think this is a good time to start the debate?
I think I don't think we need to wait. I think we have to just be careful about what we presume will happen, because, you don't want to get so far ahead of what we're actually able to do that it's purely speculative and completely irrelevant. But I think we don't just focus on our feet, right? We have to look ahead and do a little horizon scanning as well.
Wonderful. Thank you, Sarah. So now let's have a conversation with Jamie, with John, with you, Sarah, and we'll talk with you, and you can ask questions to each other as well. And then we'll take
I definitely have a question.
Yeah, go for it. Yeah.
John, I'd love to hear you. You did such a fantastic job in the film and in other work I've seen from you, laying out the horizon that Sarah just described. So can you talk a little bit, we've talked about it a bit more in the medical health space, but this idea of performance enhancement. I have a background in education. I did education technology policy in the Clinton administration. And what's the way to think about that going forward in everything from how we learn as children and where this can go to how we perform as adults and increase our capabilities as adults. So I'd love to hear your thoughts about both where we are and as you think about that going forward, what the applications might be there.
Well, I think that, we already have a brain interface with our desktop computer. It happens to be our hands or our voice or eye movements in some cases. But so we directly interact with that machine. And I think I think the fusion of all the capabilities of a digital computer, which is radically different than the way our own brain works, But to merge those two together is extraordinarily powerful. As you know, fast information processes is used to generate wealth in the stock market, for example.
Right.
If we could take the insights and intellect of us and merge them with a computer, we can already do that. We can.
Right.
But now the question is, can we get a channel that goes directly from our brain into a computer, so we're going back and forth faster than we do with the interfaces that we were born with? So I'm a little skeptical, but I could be wrong. And that is, can our brains handle information that's at a rate faster than we can actually deal with it through our ordinary interfaces? And I would at first say, I don't think so. But then even if you take a look at something like driving, we evolved without ever the ability to drive 150 miles an hour. And yet that's about the limit of humans can process that information and do quite well. So if we were able to speed up the rate at which information from our digital computer went into our head, we would probably, we could be then back and forth interacting with the computer, and it would radically transform our capabilities, I think. So I don't rule that out. I think it's a little bit challenging. The big one, of course, is that you need to have surgery. I think, Sarah, you mentioned that we wouldn't know it, but anesthesia, takes you out of the picture, and it also gives you a little bit of retrograde amnesia, so you might not even remember the events leading up to the anesthesia event. But I think right now that's unlikely. Could there be forced implantations? I mean, there are plenty of movies and books written about ideas like this. So, I think that's why we really need to be careful about saying, what are the sci-fi versions of getting implants into the brain? What are the avenues that we could exploit to change our interaction with a computer, if it does happen in 10, 20 years, so that the uses are good for good and not for lots of untoward kinds of things.
If I could follow up on what John was just saying. So the implantable neurotechnology, whether you're awake or not, aware of not, it still has to go through a neurosurgeon. And there's a whole procedure in place in medicine and a whole set of ethical rules, medical deontology that goes back more than 2,000 years to ensure that any device or any method that's used on humans is safe, and it will lead, it's used under the principle of beneficence to help the patient, justice, treat everyone equally, and dignities. Those are the famous principles of the Belmont Report. So
as long as everyone adheres to those, but that's
right.
That's the important piece. And we know that there are examples of most of us would have thought those were common sense ethical principles that would have existed at least for the last 100 or 200 years. But of course, there have been some horrific violations before we had instruments like the Belmont Report.
Yeah, but I wanted to bring in the non-implantable neurotechnology, because that's not part of medicine. So those are devices, again, like helmets or glasses or diadems or bracelets, that are considered consumer electronics. They're essentially not regulated. And although they're still pretty primitive in the abilities that they can do, there was a couple of papers this year, which at least I was surprised, because it showed that these advancements are coming very quickly, probably through the stimulus of the brain initiatives and all over the world. But there was a paper from Facebook using non-invasive methods. In fact, I can even share my screen. This is one advantage of the Zoom meetings. So this is a paper, I don't know if you can see it, which they're decoding speech with non-invasive brain recordings using MEG or EEG. So I know a person whose brother is lock-in, so he's in one of these lock-in syndromes at home, and they're desperately want the medical help to be able to connect him to the outside so that they can talk to him and he can talk to them. No? And a method like this could be life-changing for this person, for him, and for his family. You know, because you will be able to maybe have at home a non-invasive device, an EEG helmet, or an MEG will be a little harder to have at home. But start to be able to decode speech. In this case, let me point out that they're decoding sensory speech, not motor speech. In other words, they're decoding the sounds that come into this person's ears, and they can decode them by analyzing the EEG or MEG signals. But they haven't decoded the words that the person wants to speak, although that's the next step. No? But to their credit, this is a team from the private industry, from Facebook, at least based on their email. And my hat's off to them for their piece of work. And to their credit, at the end, the last comments in their paper, I wanted to show you this last comment, which I thought was also inspiring. This is the last paragraph in their paper, that the scientific community should be vigilant that these techniques will not be adapted to the code brain signal without the consent of the participants. So this, I think, this paper by itself opens the possibility of at least the discussion that maybe non-invasive neurotechnology should be regulated with respect to mental privacy, because here they've proven that you can start to decode speech, at least some parts of it, and obviously the next step is motor speech, and this would be definitely beneficial for many people, like this person I'm talking to you about, the private person, but they could use it in people that are normal. No? And the other paper I wanted to bring up to your attention, I don't know, John, if you caught that one, or Sarah. It's from another group that use another non-intrusive or non-implantable neurotechnology to enhance memory. And let me just share my screen. So this is a paper that came out in Grover Nature Neuroscience. Again, this is transcranial. So you have a device that's sitting outside your head. You can have it at home. And they work with particular methods, and they use they test some patients that have some memory problems, and they improve working memory, and up to a month. So this also opens the possibility of using mental augmentation. I would argue it's around the corner, because maybe we can all improve our memory using this neuromodulation. I think it's I wouldn't recommend people to jump and do this. This is, again, one scientific paper needs to be replicated, but it's very promising for helping patients, but also because it's a non-invasive method, it causes the worry that maybe what if you were to use this method on people that they don't need it. No,
I would argue that it is invasive, but what's maybe more important is I think this is the use of a technique that has actually been used to affect mood. That is, there is already a device that you can use to magnetically stimulate the frontal lobe of people with depression. And that's a FDA approved therapy that works very well in helping some people with depression, and a session of stimulation or a few sessions of stimulation will last for months. So this is a case of using something like this for medical applications, but you could imagine now exploring the use of stimulation to augment sensory activity, to augment memory or any other function, and there's no reason. The brain is a sort of electrochemical organ. These stimulation paradigms can affect the brain from the outside. So, I mean, there are lots of reasons to believe that, we could easily affect the brain. Carl mentioned one, which I thought was really striking, was making the neurons very light sensitive, so sensitive that you could shine the light right through the skull.
Yeah.
So I think John, I think that's another reason why we have to watch out for invasive and non-invasive. I mean, what we have is techniques that can influence the brain from wherever they are, whether they're environmental, which is probably the most frightening, and then those that are on the head or those that are in the head. You know, the sort of those three categories.
Yeah, sorry. Yeah,
Can I jump in too? I think this is a really good reminder about invasiveness and what we mean by that. And then I guess, you know, I think so when we think something is invasive, whether it's coming from outside the head in the environment on the skull, you know, or inside of it, what is it that makes it invasive? And I think this is where it is altering something about the way that we fundamentally take ourselves to be, whether that's as an individual or as a human. And some invasive things might be preferred, right? So, you know, if I'm living with depression and I have a very difficult time and I can get this invasive stimulation that shifts that for me, then I'll celebrate that invasive alteration, but it's the protection of the thing that I care about. And I think that's where keeping the humanist in the room to focus on how do we preserve those things, even as we're, you know, trying to address other functional needs. It's hard to, you know, specify the boundary around the thing that is being protected, but I think that's partly what we're trying to do.
I think Jamie,
Raphael just mentioned two things. So I am quite convinced, actually, the flow device that Colonel has, there's a reason it's called flow. And obviously in that case, they were not going to the FDA approval. It was a wellness performance product. But the ability to get into a flow state and remain there for a longer period of time is one of the key to learning, right? So that is one form of performance enhancement over time that you would see where you would see it used. The second thing you'll see here is I was just with the filmmakers who did Icarus, which won the Academy Award in documentary, which was a performance enhancement movement by an authoritarian state for the Olympics in that case. So I think you're going to see the performance category also move forward, where it will be in application anywhere that you can get an edge, whether it's for commercial purposes or some other state purpose. But the other part under the state is there's also the idea of there's a problem where there's also the idea of what I call the shadow, and that some of the other panelists will get to there later. Where in the shadow, because there is an awareness that this is now maybe possible, you would see in China and other places where you can have the idea where workers with helmets are students wearing something that they can be made to think that it's working. And so even if it's not working, it can be used as a source of control to make people think it's working. And so we want to be concerned not only with its actual usage, but also the shadow uses of it, where where there's a public fear that it might be used as well. And I know other people will talk about it in that context later.
Thank you. So if this is okay with you, we can start to take questions from the audience now. There's a question, anonymous attendee. May you say the commercial name of the non-implantable device that can stimulate the brain in order to treat depression magnetically, or maybe the medical name? So this is for John.
I think there are several companies. I'll look up the name. I don't have it at my fingertips. I'm not sure I remember the exact name of the company, but I'll get it for you now.
So why don't we go to another question? Jen French, as neurotechnologies develop further, there is potential for a wider divide of those who have access and those who do not. To address the issue mentioned by Jamie, what suggestions do you have to help address access and equity? So this may be a question for Sarah or Jamie, either of you, both of you.
In the health and medical context, we're going to have to look about, obviously, the extension of insurance coverage and other direct forms of grants from government or from other organizations. The second thing, as it relates to performance and how this moves into the workspace, education, et cetera, we're going to have to look at potentially ways to increase maybe the access to grants, lending capacity, and other things to allow people to sort of keep up. If they want to have access to it, how can we, make sure that both to reduce the cost of it so people have more access, but also potentially increase the affordability in other ways. We have we do that for access to higher education itself. But I think we're going to have to go down that. The government or the organizations are not going to be able to pay for themselves. We're going to have to do things to like make sure that individuals have awareness and access and affordability as well through other more innovative means.
I guess, yeah, I think it's a huge problem. And, you know, you can come back to the fact that we're in a healthcare system that is unjust to start with, never mind adding in this kind of brain altering technology. I also think, though, that we want to pay attention to the people who are part of the early studies to make the technology possible, and just thinking about ways that we support them through the study, beyond the study, getting upgrades if upgrades are available, because these are people who sacrifice something, take on risks in order to help the technology go on. And then we don't want to leave them behind in the process, right, as the technologies continue to develop. So I think there are both those future disparity issues, but then just a protection of, you know, what we might call brain pioneers who are helping move the field forward now.
Thank you, Sarah and Jamie. So here's the question from Diego Saldivar. What about exploring horizons for neuro games? Using BCI in entertainment might put users more at risk, the same way current gamers' privacy is at risk. What questions should we start asking ourselves as users and developers? As a neurogame developer, I have been advocating for a few years about best practices being established before the neurogame market opens to the public. So who wants to answer this question? Neurogaming. Sarah, have you ever done any work with ethics of gaming?
No, I have not. So, one thing I would say is, I think talking to technologists about it who are more in the gaming world, you know, one of the things might be setting up protocols that allow for transferring neural data that helps to drive the game or is required for participation in the game, but scrubbing any other content before it gets shared, right? And so if there are ways to separate out things that a user might want to protect for their privacy, making that very clear as a regulatory matter or advertisement or consumer protection on the game before it's sold would be effective. But I am not the technologist to know how feasible that really is.
Mm-hmm.
I know, John, you had a comment there. I'll just say to tee up, like, this is one of the places I've talked to Tristan Harris at the Center for Humane Technology and people in the game space and others. Here's the reality. We have released a set of persuasion and behavior modification technologies in other forms, right, on the public, and just sort of tested them on the public. And as much as I used to work at the FCC, Federal Trade Commission, et cetera, there is not an appropriate regulatory structure right now for these other kind of super powerful technologies, and that are not part of the FDA path, but have impact on the public in a variety of ways. And I think this is a key area that we're going to need more thinking, discussion, and ultimately more innovation so I really appreciate the question. And I think we need to engage the industry, right, in that, to like be part of that. But I think we're going to need to move faster than allowing for self-regulation in the industry. I think it's going to have to be in the public domain, including in government, to talk about how do we approach it in these categories.
Thank you. John, I think you found the answer for the earlier question. You want to?
There are several companies. I just found two, Neurostar and Mag Ventures. But the important thing is that they make the devices, but those are medical devices. And so for people who wanted to undergo the therapy, they would go to a medical center, and a psychiatrist or a neurologist would be the person who would set up the prescribed therapy. And it's a very specific regimen of treatments, I think, on a regular basis. It's clearly been, in at least the videos of patients that have undergone the therapy, it's been quite successful in at least some people. So the idea is it's repeated magnetic stimulation of the frontal part of the brain for depression.
Thank you. I think Marielle Kalkach says, discusses the possibility that another company is NextStim. I don't know if you've heard of them. NextStim, maybe they also are involved in that.
I put it in the answers and on live so people could see, have
Excellent.
the name if they wanted them.
So,
But I think, the boundary, the rules that regulate affecting the brain, whether there's things that are inside or outside, I mean, depending on what you want to accomplish, we'll be able to do things in all of these different domains. So I think what we need to think about is not, where is it delivered, but how do we regulate it? If you're able through the environment to affect the brain and give someone an advantage I was thinking more about like in poker or something like that, where, we actually use brain computer interfaces in the sense that we watch tells that individuals have. So that's a kind of neural give, because your brain actually creates a facial expression that you don't want to have, and it gives away, your status in the game. It's we could have devices in our heads that were better at recognizing tells.
Yeah.
I mean, these are all not outrageously crazy ideas. These could be done. The point I tried to make with the cheeseburger example is, if you have that much kind of information, do I want a rare cheeseburger on a sesame bun with lettuce and tomato? There's a lot of information, surprisingly, there that we're pretty good at conjuring in our own head. But the way for us to put that in completely it is still very, very complex, but it is a pattern. And, maybe we can learn to get that pattern. So I think no matter whether we put it in from outside or inside the head, we need to have regulations that think about the kinds of problems that are created when we can intervene like that, get extra information.
I'll just say quickly, I'm in favor. I mean, I think a promising direction is some new faster track for these approval process, where there's a standard created for the level of influence it might have. And it's not an FDA track, but it's also not something that just puts the onus completely on the consumer to know what they're using and clicking on it after the fact. So I think there's a track there. I noticed in the question that we've had before also is that part of we got to be very aware is what are the permissions that the consumers are giving up when they check a box saying that they're ready to use the product. And so are you giving away all your brain data? Are you what are the things that we're actually now expecting the consumer to know? And we've now transcended sort of the traditional consumer kind of rights. We're now into different kinds of categories, both on influence and in the use of brain data for other purposes, even if anonymized in the future. And so both testing for its impact, but also reimagining what user permissioning is. And maybe it's not for all time, user permission for all time. When you check that box, there might be check-ins or clawbacks are ways for us to think about the relationship between a consumer and one of these platforms.
We're running out of time, but maybe one last question. Boke van Valen, can you explore a little further the distinction between mind or thought reading and decoding intentions from the brain? Are we talking about mind reading, or is an intention, for instance, to move something different? And if so, how? I could jump in on this one, or maybe John, you can take it. I mean, I would argue that we don't know what a thought is. So it's hard to decode something that you don't know.
Yeah, I think we don't know the difference between an intention and a thought and the mind, and all of these things are sort of, I mean, someplace there are kinds of patterns going on in the brain that are related to the mental activity, but we don't even know how we produce those thoughts or how they are realized in our brain. And it's still when you think about it, how magical it is that what comes in our eyes winds up as this visual image that at least we think we see, and even what does that mean that we think? So these are deep philosophical questions. Sarah, I'm sure this is a wonderful intersection. It's a fascinating intersection that's developing between philosophy and neuroscience about, I think most of us believe that there's electrical impulses releasing chemicals in our brain that happens in all kinds of animals. And it happens in us, but something happens in us that gives rise to a kind of consciousness that seems to be very special in us. But how that's realized is, I think, one of those really deep and difficult questions.
Can I,
Sarah,
I know we're out
what
of
if
time.
this-
Can I just
Yeah,
have a
I'd
word?
like to
Rafa?
get Sarah, please.
Yeah,
You're
I
on the
mean,
spot.
I think in talking about this, we regularly get pushback. Is this mind reading? I don't think there's anything that can pull a thought, right? I don't think they're separable in that way. So it's not mind reading in that sense, but it's reading of neural activity, which is what underlies whatever we're calling our mind and our ongoing dynamic processing. And it's really then not reading so much as it is interpreting that good enough so that we can then do something with it, right? Whether it's moving something externally, communicating because we've lost other pathways to do that. And I think we have these amazing technologies that show that it's possible to interpret it with training, right? And it's not simple or easy, but I think as we get better at that, inevitably, we're likely to think of it as functioning in a way as mind reading. It's, again, not one, the Pontiff of Harry Potter pulling a thought out, but having recording that provides us good enough interpretation that we know what's happening in there. And, it's a mystery, as John says, in many ways. It's an amazing thing of what we can do with these organs.
That's actually the spirit of the Herzog movie. The theater of thought is precisely the mystery of how that happens. How does the activity of the neurons generate the mind, and that explains the title, that our minds are like a theater of thoughts. Anyway, so with those this comment, we're going to finish the first panel. Thank you, Jamie. Thank you, Sarah. Thank you, John, for participating. You're welcome to stay for the remaining of the conference, but I'd like you to also, we have a lot of other questions that I haven't had time to answer, but you can help answering them in the chat. So you can, if you click on the Q&A button, you'll see all the questions, and you can type an answer, and then that answer will be sent to everyone else in the meeting. And even though if we start the second panel, these people that ask all great questions, but we just don't have time to answer them all, at least they'll get an answer. Everyone will find out. Is that all right? And with that, let's pass on the baton to Stephanie Herman, who's going to be moderating the second panel. Stephanie is a lawyer. She works for Perseus Strategy, and she's also works for the Neuro Rights Foundation, and she's an expert in human rights with respect to technologies, and specifically neurotechnology. So Stephanie, you can unmute yourself, and Lux, if you can turn on the videos for the panelists of the second panel, then we can just get started.
Hi, Rafa. Thank you so much for having me. So I'm looking forward to moderating this panel alongside our speakers. And again, we're featuring Rafa wearing one of his other hats, so going from panelist to speaker. So this panel is about neuro rights, moving the conversation beyond what the technology's capabilities are and what the potential challenges or opportunities there are for individuals' civil and human rights. So our speakers will be Rafa, as you know, the chair of the Neuro Rights Foundation, a professor of biological sciences at Columbia, and the director of the Columbia Neurotechnology Center. We're also joined today by Jared Genzer, the general counsel for the Neuro Rights Foundation, as well as the founder and managing director of Perseus Strategies, a public interest and human rights law firm. And we'll be joined by video by Alan McKay, who holds numerous positions at the University of Sydney in Australia, including as an academic fellow at the Sydney Law School and as the deputy director for the Sydney Institute of Criminology. So thank you all for being with us today. I'll hand things over to Rafa to get us started. As one of the original thinkers behind the concept of neuro rights, please tell us, where did this come from and how did this conversation begin?
Thank you, and here I am again. I'm going to switch hats now. So this actually started with the Brain Initiative, funny enough. So I was part of the group that first proposed what became the Brain Initiative to the Office of Science and Technology Projects of the White House in 2011, after a meeting at the that happened in England, a brainstorming meeting with the idea was generated that we really need a push in neurotechnology to move the field for scientific, medical, and economic reasons. And in this initial proposal to the White House, we alerted the White House team that this method, again, this is not any organ that we're dealing with, this is the brain. And just as we heard before, so this leads, if the brain generates all the mental activity, we know that for sure, there's no mental activity that is not generated in the nervous system. And if technologies that let you read and change, record and change brain activity, by definition, will enable you to decode and change mental activity. No? So we thought that these issues had to be addressed from the get-go. No? And that was actually part of our paper we published, and the memo we sent to the White House that was actually in there. No? And this led to a series of discussion that took some years, in which neuroethicists and people that have been worried, like Sarah Gehring that we just heard, and other experts that have been worried about these things for a while, brought in their perspective of what is the best way to deal with these ethical and societal issues associated with the development of new technology. And again, these things go hand in hand, just like with atomic energy. You cannot separate these things. This is the way things are. No? So this led to a meeting that happened actually here at Columbia in the Morningside campus in 2017, and this was co-organized by Sarah Gehring and myself. And this meeting pulled together 25 experts that came up from all these brain initiatives that I was just mentioning earlier from all over the world. Also experts that came from the laboratories, like myself, from science, from the clinic, neurosurgeons, neurologists, from bioethics, from the law, from and also from AI, from artificial intelligence, from the tech industry, you know, and from neurotech companies. And we hold ourselves up here, actually on this same floor, for 3 days to study the societal and ethical issues associated with neurotechnology. And we came to the conclusion that this is the human rights issue. In fact, if this is not a human rights issue, what is a human rights issue? Because again, since the brain generates the mind and the mind defines what we are, who we are as human beings, this technology goes to the core of our humanity. No? And this is the first time that this has happened in history. No, we haven't had a technology that goes to the core of who we are, to our minds, and lets us record and alter the same tissue that generates our minds. So we raised the idea that we should have human rights level protection of certain to protect population and citizens from ill-intended use of neurotechnology, to protect from the risks of neurotechnology. And we came up with this term neuro rights, like brain rights, neuro rights, and we propose 5 neuro rights: the right to our own mental privacy, so that the content of the brain activity cannot be decoded without our consent. No? The right to our own agency, as you heard from Sarah earlier, the agency, the free will, the ability to make decisions freely, based essentially on the activity of your own brain, without having it meddled outside, like we can do with mice. Again, this is not science fiction. We can do this with animals, and what you can do in an animal today, you can do in a human tomorrow, technically. No. Also, the right to our own identity, as Sarah has mentioned. Some patients, Parkinson patients, describe change not just in mood, but even change in personality after they've been implanted when the stimulator is on, and even the families of the patients are the ones who alert the doctor, what are you doing to grandpa, that whenever they turn on the stimulator, he turns into a different person. So of course, our identity, our self, is generated by our brain. Where else would it be generated, no? And if we can change the brain, we can change ourselves. And we think that the right to your own self should be the first human right. Because if you don't have the right to your own identity, what do you need the rest of the human rights for? And then we also discussed two rights with respect to the application of neurotechnology in the population. One related to the discussion we had earlier is the fair access to neuroaugmentation, so that whenever neuroaugmentation technologies are ushered in, which could be faster, as we were discussing, than we originally thought, well, they should be ushered in under the universal principle of justice. So we should work to ensure that these technologies are accessible to the population without this. And then this leads also to the last neuro rights, the protection from bias and discrimination, so that we don't end up with technology that you can use in certain people and not another, or that when you bring in algorithms with neurotechnology into the nervous system of people, you bring in also biases that could come with the algorithm, and that could actually change the way you can implant these biases deep into their mental processes. And this is something that we've seen with mice, that once we implant things into the visual cortex of the mouse interprets that information as its own.
Rafa, can you give us some examples of the application of AI to neurotechnology and sort of where the Morningside Group's concerns come from?
Yes. So the reason that we had AI experts in the group is because AI and neurotechnology go hand in hand, and moving forward even more. We need AI, we need machine learning and neural networks to decode information that we track from the brain, and to also encode information that we want to put in the brain. So nowadays you cannot do this without some serious computational effort. So that means that these two technologies are intertwined. And that's why these neuro rights we've sort of originally proposed for neurotechnology, they start to overlap a little bit with what goes on with AI with respect, for example, with the bias and discrimination. This is a problem that the AI experts brought to the table, and that we had the luxury of having one of the top people in AI from Google, and he was mentioning exactly how they deal with that problem within Google. So this is something that we adopted as part of our agenda. And by the way, I should say that we were not the only people. There were 25 of us here came up with this agenda of neuro rights. We wrote a paper that was published in Nature in 2017, and to alert our colleagues and society in general that there are human rights implications with this new technology, because it's an existential technology. It goes to the core of who we are as humans. But the same idea pretty much was made by two other investigators independently of us, who at the same time, they met in Switzerland, Roberto Adorno and Marcello Allenca, and they came up with a very similar idea. And guess what? With even the same name. So they also coined the term neuro rights independently. So there are now two sets of people, in total 27 people, 27 experts in different parts of the world who are pushing for this idea. No? So once the idea was on the table from this guy, the Morningside Group, and the Adorno and Allenca paper, then people like myself and other people, we started saying, well, maybe we should, it's good to generate ideas, but something more important is to do something with them. So let's do something practical. Again, you can wait for things to happen, or you can make things happen. So can we make things happen? Can we really usher in these new types of human rights in the public? And we started working with experts, because I have to tell you, we didn't have any experts in human rights, and this is another field. And this is like when you discover, oh my God, we really need to talk to these people. They're the ones who know what you're doing. And experts like you, Stephanie, or like Jared, who you'll hear in a second, and Alan, who you hear soon. And that's when we started making bridges with the human rights world. And this started with the creation of an initiative, the Neuro Rights Initiative, which turned into a foundation, the Neuro Rights Foundation, that we're all a part of here, to do exactly research in terms of human rights aspects of neurotechnology, advocacy to discuss these topics, to bring them to the attention of the people that can make things happen in the world, that legislators or leaders of international governments, international organizations, no? And also outreach to bring these ideas to the society in general. And this is actually what we're doing today, is an example of this. This outreach. No? So this is sort of what we've been doing. And as you're going to hear in the meeting, we've worked in the afternoon with the Republic of Chile and with the UN. And I'm not going to break the news to what's going to happen, but essentially experts from Chile and from the UN will discuss these issues with some of you. No? So excellent. I think that's pretty much what I wanted to say.
So we have a good program coming up this afternoon for sure, focusing on each of these individual areas. And we'll turn now to Jared Genzer as an expert in international human rights law to hear a little bit more about how, as Rafa said, this is a human rights issue and the different challenges and opportunities that presents.
Sure. Well, thank you, Stephanie and Rafa, and everyone watching today. I met Rafa about 2 years ago now, and a single conversation, I think it's fair to say, changed my life and trajectory. I knew immediately we would become fast friends, and also knew that I had no idea what was coming when it came to the development of neurotechnology and the impact it was going to have on humanity. And I was incredibly worried from that first conversation, not only because of the potential for misuse and abuse of the technology, although obviously the upside is enormous as well in terms of the positive aspects of developing this new technology. But I was worried because really nobody in the world of international human rights that I work with at the United Nations, with the US government, and civil society groups around the world had any idea about this topic. And I knew nobody who had ever even mentioned it to me, nobody working on it, and nobody understanding how rapidly the neurotechnology is developing and the implications that it might have in really, really fundamental ways. So it has been quite a journey, I think, for me and my team to co-found the Neuro Rights Foundation with Rafa and Jamie, and then to get to work on taking the 5 neuro rights that were developed by the Morningside Group and trying to then operationalize them in practice at the UN, at the national level, and with companies. One of the things that I think is exceptionally helpful and important to emphasize is that the 5 neuro rights were not just kind of taken out of nowhere or out of the sky, but as Rafa described, came from a group of experts, not human rights experts as such, but although there were some ethicists there as well, but primarily from scientific experts on the technology who could imagine, researchers, scientists, technologists, et cetera, who could imagine the ways in which this technology could be misused or abused, and therefore were able to identify areas of concern that could be potentially human rights concerns. I think that what we've tried to bring to this entire debate and discussion is to take those potential risks of misuse and abuse identified by these 5 neuro rights, and then overlay on top of that the international human rights protection system that has developed in the 20th century. As everyone knows, the United Nations was created in 1946 in the wake of the end of World War II to prevent the scourge of war. In 1948, the UN General Assembly adopted the Universal Declaration of Human Rights, which was the first attempt by all of the countries in the world, and the only attempt actually ever ultimately, to identify a set of fundamental human rights that are in fact universal and apply to all people in all contexts and all situations of all backgrounds from around the world. that Universal Declaration was a proclamation of the international community's commitment to respect these fundamental human rights. But these were not binding legal commitments as a matter of law. And ultimately, there have been a dozen treaties developed since then that are multilateral agreements across states that have codified different aspects of the rights that are found in the Universal Declaration, as well as other specialized rights as well. We'll have obviously a session this afternoon on the role of the UN in all of this. But this discussion, of course, is focusing on, on the human rights and neuro rights, that we've been discussing. And what I would say is that, and again, we'll get into this in more detail in the afternoon. When you look at the 5 neuro rights, some of them are in various ways already protected by the international human rights system that we already have. For example, if at some point a person were to use neurotechnology to inflict pain on a person, psychological or physical pain, then the UN Convention Against Torture would already prohibit that kind of misuse or abuse of neurotechnology. But ultimately, what we've been finding and looking at this is that in order to understand the gaps that exist, one first has to understand what rights does the international legal system already provide. And then look at what are the risks of misuse and abuse of neurotechnology and see, what might already be protected, where might we need to extend the interpretation of certain rights in order to cover these new neuro rights, and what gaps might exist that would need to be filled that wouldn't be covered or couldn't be extended from an existing set of human rights. Yeah, please.
I'd like to ask you a little bit about, if you could explain for the audience the relationship between international human rights law and how that filters into domestic regulation. We heard on the last panel about some of the concerns around consumer neurotechnology, lacking regulations. How do we get from this global picture to domestic laws that actually protect neuro rights in the US?
Sure. A great question. An important question, especially if you're not an expert on the topic, as I would imagine most people watching this are not. International human rights treaties are multilateral agreements of countries around the world that sign and ratify those treaties. To take one example, there's a treaty called the International Covenant on Civil and Political Rights. It's been signed and ratified by about 175 countries around the world. It covers about 92% of the world's populations. It includes in it rights such as the right to freedom of opinion and expression, the right to freedom of thought and conscience, the right to freedom of religion, the right to peaceful assembly, the right to political participation, and so forth. And the way this treaty is written is that the treaty says that if you sign and ratify it as a country, as a government of a country, then you must immediately bring your domestic law into compliance with the requirements of that treaty. And every treaty every international treaty that's adopted, human rights treaty that's adopted by the UN, like the International Covenant on Civil and Political Rights, has what's referred to as a treaty body that is associated with it. And this is a group of experts elected by member states of the treaty that are elected officially, and it's their job to provide the definitive interpretation of what the treaty means. So, for example, Article 19 of the International Covenant on Civil and Political Rights has a right to freedom of opinion and expression, and that treaty body has adopted about a 20 or 30 page, what's referred to as a general comment, that goes beyond the relatively brief text of the treaty itself to explain in detail what is meant by freedom of opinion and expression, what limitations can properly be placed on opinion and expression, for example, to protect, against national security concerns or public morals, and that general comment gets into much more detail. The way that international law intersects with domestic law is that upon signing and ratifying the treaty, every country in the world that has done so needs to bring its domestic law into compliance with international law, if a country, for example, has fewer protections, on freedom of opinion and expression and in essence restricts it substantially, like an authoritarian regime might do, then this would be a violation of their obligations under the International Covenant on Civil and Political Rights, because every country that signs and ratifies the treaty has to provide freedom of opinion and expression in its own country in a way that is consistent with the requirements of the treaty and how that treaty has been interpreted by the treaty body that is elected by the member states of the treaty. So I think that when we're talking about developing neuro rights and operationalizing them, one of the things that could happen, for example, is if you were to take the right of mental privacy, you already have under international law and under the International Covenant on Civil and Political Rights, a right to freedom of thought and conscience. And that provision is interpreted to say that that a state cannot arbitrarily interfere with freedom of thought and conscience. But it doesn't necessarily mean that you couldn't, it wouldn't necessarily be a violation of that provision if a person's thoughts were being monitored, but not interfered with. And so one thing that one might want to do is to extend out or to further interpret that provision of the treaty to say that it isn't just about arbitrary interference, but any monitoring of anything within a person's brain without informed consent would be a violation, both of a right of freedom of thought and conscience, as well as a right of privacy, which is also embedded in the same treaty itself.
Excellent. Thank you, Jared. And so at this point, we've heard a little bit about the evolution of the concept of neuro rights, a crystallized analysis of how this is a legal human rights issue in addition to an ethical quandary. Now we'll turn to Alan McKay's virtual presentation, video presentation, to hear a little bit more about domestic contexts. So in-country contexts under national law, where neurotechnology puts some of these human rights issues on display. So Lux, whenever you're ready to start the video. Thank you.
Lex, we cannot hear. I don't think the audio sound. Yeah. Yeah, we tested it yesterday and it was working, so just a little glitch. No, we still cannot hear it. I cannot hear it. Can you hear it, Stephanie?
No, I can't.
So Lex, can you ensure that that little box is clicked when you share the video, and that the volume is up? I think you had the volume up. Yeah, we just have to, you have to share the audio as well. Yeah. You may have to unshare and share it again. That's exactly, that's what I would do. And then now when you share it, just make sure that you click this button on the lower left that enables you to share not just the video, but also the sound, just like we did with the other videos. Yeah, I'm sorry about that. We had it working yesterday when we did the test. No. Well, one thing we could do is while we're fixing this problem, have a conversation. Yeah, go to the Q&A and then circle back.
Certainly.
But it's frustrating because yesterday we had it working. I was we precisely to avoid this issue we did a test, and yeah.
All right. Well, in that case, let's get started with some Q&A. And if we're able to get the video presentation working, Alan can provide additional perspective as we start to answer many of the questions that his research undoubtedly addresses. So I'd love to hear you both, maybe in conversation, talk a little bit more about what the role of industry is in protecting neuro rights, what its involvement should look like, if at all, what it means to promote the ethical development of neurotechnology devices, and especially, what should be the primary goal of any forthcoming regulation on industry.
Oh, here we have Alan McKay, but we still cannot hear him. Poor Alan. Lax, I think let's take the question from Stephanie. So industry plays a fundamental role, and we've been working with the industry from the very beginning. In fact, as I told you, the Morningside Group had representatives from Google, from Kernel, from other companies now. And they're very interested. I mean, just from personal experiences with IBM, with Facebook, with Google, with Microsoft, they're deeply interested in these issues. I just show you an example of a paper written from Facebook that concludes the paper highlighting the importance of being alert to the potential misuse of neurotechnology. So, but at the same time, the industry is not in the business of regulating itself, and it's to expect that the industry will take care of all of this problem. It's not realistic. This has not happened in the past, also with AI, with the internet, with social media. I mean, there's, as you know, with privacy issues, there's a lot of shortcomings of expecting the industry to self-regulate. So I think the important thing is to bring them to the table, involve them in the discussion, like we did with the original neuro rights proposal, no? And then come up with a coordinated plan where their interests are also represented, but in a way in which they are consistent with the Human Rights Convention, as Jared was saying. No? That would be my take on the industry. I don't know, Jared, if you want to say something. Jared,
yeah, sure. Yeah, well, I mean, look, I think this is going to be a process that the industry needs to go through, and the mission of the Neuro Rights Foundation is to promote innovation while also protecting against misuse and abuse of neurotechnology as well. So it's obviously always going to be a balancing act. I do think it's important for industry to engage in some form of self-regulation and to, or at least standard setting around, what is considered to be acceptable and unacceptable conduct in the way in which companies develop neurotechnology and monetize it. And the same goes as well for investors in neurotechnology. And I would hope that, even if industries can't regulate themselves, which I think, of course, I fully agree with Rafa on, that, it would be in the interest of, of investors as well as companies to create those kinds of standards, because that frankly could forestall, potentially over-regulation of neurotechnology. If there can be consensus developed among industry around what is appropriate and not appropriate, then that could be, important input into a regulation process. Ultimately, we're going to need regulation. And I think that we know this because In the field of consumer neurotechnology, there are already several dozen more rudimentary neurotechnological devices that are for sale to consumers today that do more basic functions like determining if you're in a meditative state or assisting with sleep and monitoring of sleep, monitoring concentration levels, and these kinds of things. And what one sees when you look at the user agreements for these pieces of technology is that many of these companies are substantially harvesting brain data. And so what you see in the user agreements, when any of us gets some kind of electronic device and you turn it on, you often will connect to an app, and then the app says, please agree to all of our terms and conditions. And these are often like 50 or 60-page agreements that nobody ever reads, right? And if you look at the user agreements of these consumer neurotech products, in essence, what's happening is that when you agree to use the product, you're unwittingly agreeing to upload your brain scan to the cloud and to this company, and in many cases, irrevocably giving the brain scan to the company itself to use however it sees fit, including to sell to third parties. The problem with this is that today only 2 or 3%, Rafa can correct me if I'm wrong, but 2 to 3% at most can be interpreted of brain data. And there's lots of other things being captured in your brain scan that down the road with better technology might be able to be interpreted out of your brain scan. But there could be diseases you might have, or even potentially thoughts you were thinking at the time that the scan is taken, or so forth. And so, in terms of regulating that and creating a right of mental privacy, in my view, companies, this is just my personal view, I don't think companies should be prohibited from harvesting brain data, but there should be an explicit requirement of informed consent, not just presented within a 50 or 60-page user agreement, but, on the screen, it should say, very clearly, one issue at a time, exactly what it is you're consenting to and what it means and what the implications are. And so I think that these are the kinds of things that are going to require a lot of thought and potentially regulation to try to, again, strike that balance properly between, wanting to promote innovation, but also, protecting users of this technology from its misuse and abuse, not just by governments, but by industry as well.
So at this point,
sorry, if I can just quickly follow up on, there's also something that the industry could do, and they've been very proactive, is to come up with engineering solutions, let's say, to this problem that Jared was mentioning of the mental privacy of uploading brain data so that it can be decoded with deep neural networks, or in the future with AI, like I've shown you a paper earlier. So there's at least 2 technical solutions that have come out actually in industrial labs that could prevent that from happening. One is federated learning, and this is something that came out of Google. And the idea was to keep the data on the device so that the data never leaves the device. So in this case, your brain data would never leave your BCI or your device. And the only thing that leaves the device is what the algorithm has learned on your data. So this, the lesson, so to speak, gets sent up to the cloud or to the server. So this prevents the loss of data privacy, and it's a very elegant engineering solution to the problem. And another one that came out of Microsoft, of Kristen Lauder's team, is homomorphic encryption. So there could be another way to encrypt data that is much more robust than what's normally done, and that could make it pretty much unbreakable, at least according to her, for 50 years from the point of view of data security. Sorry to interject. I thought that this
no, not at all. It's helpful to understand, of course, the scientific perspective and the limits of the applications of the technology as well. So I'm going to tie together a couple of questions that I saw in the chat. One coming, I believe, from the Electronic Frontier Foundation earlier, but is no longer viewable in my chat. So apologies for not mentioning the name. But dealing with the issue of informed consent. As Jared was speaking about the potential regulatory problems and the terms that are in the legally binding agreements that accompany these consumer products, there seems to be a massive issue in what it means to give informed consent now as a consumer but informed consent is not itself an independent neuro right in the Morningside Group's framework. So I'd love to hear you both comment on that, and in the process, respond to a question from Cohen Brown about how some scholars have challenged the neuro rights proposal for various reasons, including conceptual issues, the non-necessity of new legal protections, and so on. How do you address those criticisms, and how are you using the neuro rights framework to address new issues like informed consent?
Well, I mean, I can deal quickly with the informed consent. Actually, we discussed this in the context of our 2017 paper, and we provided also some explicit ways in which the industry can help with this process. No, but we would bundle this up within the more general issue of privacy, of mental privacy, in this case, data privacy. No, so that that's something that it's not isolated as a different neuro right, but it permeates a lot of the discussion that of privacy and also, of course, of agency and identity, because it's part of it. No, and if I could just quickly touch on this question from Cohen Brown. So there are so not everyone agrees that neuro rights, that human rights, is the way to go, and this is fine. This is just one possibility of how to deal with these challenges that we've identified in neurotechnology, particularly as it gets applied massively to the population in the future. Our position, again, is that, as I said earlier, this is not a human rights issue. What is a human rights issue? But there are other people that think that maybe this is not a human rights issue. Another question, if you do agree that this is a human rights issue, is whether do we need new human rights? Is this a case of human rights inflation? Do we really need new legal protection? So this is something that, I mean, actually, Stephanie is the world's expert in this because she did the gap analysis. I presume you're going to talk about this later. But the very, very brief conclusion is that if you look at the existing regulation of human rights versus these challenges, the existing regulations are ill fitted to respond to the challenge that we need to do something more than just business as usual. No? So, and my own intuition, like, well, if the society changes, so should the human rights change. Why should we be stuck with the Human Rights Regulation 1948 when we're now decoding speech and doing all these amazing things that you can do? No, so anyway, I pass the answer now to Jared. Jared, for your comments.
Yeah, I mean, well, I think undoubtedly there are going to be kind of lots of twists and turns in terms of interpreting neuro rights and looking at different elements of them. I think in general, of course, you already have, when it comes to medical care or psychological care, rights to informed consent. You have in the United States HIPAA regulations, health insurance, privacy regulations as well. So a lot of what we're talking about with neuro rights and a right to mental privacy is simply extending, the existing kinds of protections that already exist into the field of the brain. But it is quite different because, while it's already the case, for example, that implantable brain-computer interfaces, where a skull has to be opened and something is actually inserted into your brain, is already heavily regulated, of course, as medical devices. The consumer neurotechnology products that we've been talking about, aren't medical in any meaningful sense, and therefore the kind of privacy regulations you would see for mental health care, physical health care, wouldn't exist. There's no doctor relationship there, and overall privacy, privacy framework. I think the reality is that I think the Morningside Group did an excellent job at looking at the primary implications of the potential misuse and abuse of neurotechnology. Undoubtedly, there will be, further interpretations of what other rights might be necessary as the technology develops. But I think that the Morningside Group's 2017 formulation is a great starting point. And frankly, if we had the kind of protections in place that were needed to address those 5 neuro rights, we will have gone a dramatically far way, a long way to advancing protections that people need, both from misuse and abuse by governments as well as by industry and other non-state actors. So I think I think that we'll get there ultimately, but I think that the public awareness raising component of all of this work is especially important, and I think oftentimes the UN and national governments are the last to figure out that there is a major problem. And I think that one of the things we're trying to do, and that Rafa's been doing so brilliantly for years, is to be the canary in the coal mine as someone who's both, I guess, doing the mining, if I continue with that analogy, but also worried about the mine blowing up. I think Rafa's both the miner and the canary simultaneously, and I think that that's what we really need, because I think that as we travel the world as we've been doing and engage with people at the UN, in national governments, in civil society, and with industry, it is extraordinary how little people know about how fast the technology is developing and the risks of it being misused and abused.
Well, thank you, Jared. Thank you, Rafa. I'm hearing reports that Alan McKay's video is now working, so we'll turn to his presentation.
Thanks very much for the invitation to speak at this important event. I'm sorry I can't be there in real time because I'm on the plane, but it's an important topic, and so I'm going to talk about neurotechnology and human rights. And of course, neurotechnology has fantastic capacity now in terms of doing things like decoding mental images and treating a variety of conditions that require intervention, such as epilepsy, Parkinson's disease, depression, and locked-in syndrome, enabling a person with locked-in syndrome to communicate again, to control a cursor or a device. So of course that's wonderful, but there's still there's some important issues to think about. Hence this event. I think it's useful to think in a broader context. So the evolution of the ethical and legal frameworks, which we live by, they evolved in circumstances which didn't involve the use of neurotechnologies. They involved in situations where the contents of our mind were private, unless we disclose them in some way. We act through our bodies and perceive through our senses. And legal doctrine evolved with similar presumptions. So I lecture in criminal law, and I became interested in the question of what the criminal act, the actus reus, as we lawyers call it, might be in the context of somebody acting by way of brain-computer interface instead of using their muscle system. That's an interesting sort of doctrinal question for lawyers that I've written about. But then discussions with Rafa and others alerted me to the human rights dimension to it, which I really think is very important and worthy of consideration now. And so this event is great. So if we think about the post-World War II human rights framework, that evolved with different kind of issues in mind. It evolved with a view to preventing the recurrence of some of the terrible occurrences in the gas chambers and so forth of World War II. And the drafting committee and Eleanor Roosevelt and the others on the drafting committee didn't think about brain reading technologies or technologies that might even intervene on our brains and influence behavior. So there's a reason, sort of prima facie reason to think, well, maybe the human rights framework might not be fit for purpose now. And before going into that, I think it's worth considering some of the other applications. So of course, therapy Therapeutic applications are very important in neurotechnology, but some people are starting to use neurotech for gaming. Perhaps one day it might turn out that neurotech's a good way of interacting with the metaverse. Military institutions have got a long-standing interest in neurotech, particularly DARPA, the Defense Advanced Research Project Agency in America, and they've got a continuing interest. And we might see soldiers with enhanced capacity to pay attention and proceeding through the battlefield, controlling a drone swarm by mental act instead of by using a joystick or some sort of bodily act. And we might see the expansion of workplace monitoring. There's already a kind of surveillance culture in some workplaces, and at the moment, perhaps, well, neurotechnology is used occasionally to monitor attention of somebody, say, for example, driving a heavy goods vehicle or something, and there's not really wide uptake in the employment context, but that could expand in criminal law. So that's my area of interest. We already engage in electronic monitoring of offenders, and I can imagine that expanding to monitoring the brains of offenders who are impulsive or aggressive, and perhaps electrically stimulating to calm them down by way of some sort of automated process, so that they can serve their community and serve their prison sentence, serve their sentence, I should say, in the community. But of course, that starts to raise human rights concerns. What about the mental privacy of workers? What about the mental privacy of offenders? Is it right for their brains to be monitored 24/7? Is that an infringement of mental privacy? What about the manipulation? Like if we start to electrically stimulate or otherwise stimulate offenders' brains to alter their behavior, that seems to involve a sort of manipulation, and it seems to be a threat to autonomy. What about that? So those kind of issues, of course, weren't being considered in 1948, in the aftermath to World War II, when they drafted the Universal Declaration of Human Rights. Why would they be? And so you might think, well, you can just opt out of neurotech if you're worried about mental privacy and if you're worried about autonomy. But it might be hard to, for a while I stayed off social media, and then eventually everyone else was on it, and I just felt like I was missing out. And here's me doing a selfie, and I sort of got with the program, and it might be hard to avoid neurotech if it, say, for example, it provided a useful solution to some kind of ailment or mental condition, or, for example, others in the workplace, they were, say, using neurotech to cognitively enhance, improve their attention, and out-competing you in the workplace. So there might be a pressure to use neurotech. And so we can ask what's to be done. It seems like neurotech might expand in the community. That seems likely. There's a lot of investment, a lot of excitement, there's scientific and technological progress. So neuroethicists have to be involved, and they have. There's a long-running neuroethical discussion of things like deep brain stimulation and that sort of thing. Legal scholars are newer to the field. There are some legal scholars that are starting to pay attention now, but there's clearly a legal dimension to it. So that needs to keep going. The other thing is just engaging the public. So Rafa has And the Neurorights Foundation has engaged in a documentary with Werner Herzog. That's a great thing. Neurotech companies and regulatory bodies, they need to be engaged. So I, for example, am involved in a forum in Sydney where we're getting regulators, people from neurotech companies and lawyers together later this year. Lawyers need to be engaged. So, for example, the Law Society of England and Wales, they recently published my report on the future of law and the legal profession in light of neurotechnology. I'm doing a talk for the Istanbul Bar Association. There's been various practitioner publications that are now starting to take note, and responses from some of the large commercial firms. No, I think that's a good thing. I think it's good to engage lawyers because in time, law reform will be needed, and people in law reform commissions are lawyers. And if there's a discussion in the profession, then that will help. And then, of course, as you'll hear, there are global and regional bodies involved. So the United Nations Human Rights Council has recently taken action on this in terms of getting a report, and some domestic legislation has taken place. For example, in Chile with the constitutional change and the neuroprotection bill, and in Argentina, where I understand there's a current bill. Now, all these things I think should go in parallel, and they're mutually reinforcing. And these things need to keep going. And I think the final point to just end on is some of this involves thought and some of this involves action. And there's got to be the right balance between thought and action, because the technology is moving fairly quickly, and we can't spend too long thinking. So thanks again for the invitation. Thank you very much.
All right, so unfortunately we are out of time for this panel, but I hope you all enjoyed getting to see Alan McKay's presentation. We'll break at this time for lunch, but don't forget to come back at 1 o'clock for our next panel. Thank you again.
Rafa, ¿cómo estás? No te escucho, está ahí apagado.
Estás
Espérate.
apagado, Rafa. Hola,
Yeah.
Rafa. Hola, Guido. ¿Qué
Hi
tal?
there.
Buenas.
We are
Hello.
we're going to be speaking in English. Sorry, guys.
Okay,
And
perfect.
we're
We'll do
waiting
it in
for.
English.
And Guido, I will translate the questions and translate your answer back into English, so you don't have to worry. You can talk in Spanish, and I will do the translation. Moises, can you turn on? Yeah, sounds good. Moises, can you turn on your camera? Good afternoon, everyone. Welcome to the afternoon session of the Neurotechnology and Human Rights Issues and Progress meeting. In the morning, we discuss neurotechnology, both scientific, medical, and ethical issues. And we also discuss human rights. We talk about neuro rights and legal implications of neurotechnology. And this afternoon, we're going to be discussing two specific cases where a human rights approach to neurotechnology is being either followed or at least considered, the Republic of Chile and the United Nations. And after that, we will finish with a closing session in which Sar Lively will launch the NeuroH magazine. So the panel now has to do with Chile. We are fortunate to have three great panelists. I will act as a moderator, and I will also act as a translator because to help Guido Girardi participate in the panel. Guido is an ex-senator of Chile. He's a very well-known person in the Republic of Chile, and as a senator, he was the head of the Committee of the Future of the Senate, which sponsored the constitutional amendment for neurotechnology and human rights in Chile, and the Bill of Law, which is currently under discussion in the Chilean parliament. Another panelist is Moises Sanchez, who's a human rights lawyer. He's an expert in inter-American human rights, and he's the executive director of the Camanao Foundation, and is interested in neurotechnology and human rights. And the third panelist is Carlos Amunategui, which has a very nice Basque name, which I think means the place where you have the thistles, I think it is, in Euskera. And Carlos is Chilean as well. He's a professor at the Pontificia, at the Católica University, which is one of the most distinguished universities in this country. And he's an expert also in legal issues and issues related to technology and human rights. So maybe to start, I'm going to ask Moises to speak first, and Moises can probably describe us what has happened in Chile. Just assume our audience knows nothing about what's going on in Chile with neurotechnology and human rights. What has happened? What has happened also in other parts of Latin America that I think Moises you're familiar with, and then if you can just get a start with that, and then we'll ask Guido the question, that burning question that some people have already asked earlier in the morning, like why Chile? What does Chile have to do with all of this? And to explain the role that he had and the Senate of the Republic had, and then Carlos, maybe we can talk to you about the future of what do you think will happen in Chile and Latin America with respect to human rights. And this, you can also, every one of you can bring whatever idea you want to the table. These are just some guidelines. So Moises, if this is okay, you have 10 minutes to make your initial remarks, and the floor is yours.
Thank you, Rafa, and thank for the Neuro Right Foundation for the invitation to this seminar. I know there are many Latin American participants in this seminar, and for that reason, I speak in Spanish. Easy for me. Quiero partir haciendo una...
Wait, but if you speak in Spanish, I'll have to translate.
Yeah.
Can you speak in English since we had the whole symposium was in English? Is that possible?
It's very difficult for me. Sí.
Yeah. Okay. So why don't you talk in English and then I will help with the Spanish. If oh, sorry, you said that it's difficult for you or it's easy for you? I just
no, it's difficult for me. Oh, maybe maybe I can try in English. If I have some problems, can you help me?
Yes, I will. That's exactly my job.
Thank you, Rafa. Thank you. I have three great ideas in my presentation today. First is about the Latin American agenda in the neural rights and problems, situations, advance, and some regulations, international regulations in our region, in Latin America. The second is some reflections about the international standards, especially if we consider the importance of the Latin American in the global context. Latin American have in human rights many importance because the standards in all regions are more have in many times more advanced, is more progressive than other regions in the world. And the third idea is some next step about the Latin American countries. They have some advance in national legislation, like Argentina, Brazil, Mexico. And in order to start, my first idea is the some chronological description about the neurotechnology advance in our region. In 2017, Rafa and the Monisai Group published the 4 ethical priorities in neural rights. This document was very important for advance and put the agenda in the table. It's very important. In 2020, the IBC of the UNESCO published a very important report about neurotechnologies and human rights. And in the conclusion of this report, UNESCO expressed their preoccupation about the human rights standard in neurotechnology topics. Was a very important advance. In 2021, we have the first very important advance in order to international standard in the Carta de Derechos Digitales de España, the Bill of Digital Rights in Spain. This chart have some chapter about neuro rights, neurotechnologies, and in my opinion, is the first document that incorporate the neuro rights formally in some standard. And in the August, in the same year, 2021, the International Juridical Committee of the Organization of American States published a very important declaration for Latin America about neuroscience, neurotechnology, and human rights. This declaration was prepared with a very multi-stakeholders committee. of experts. Rafa, you was expert in this committee, and in this month, this committee of the Organization of American States approved this declaration, and this movement, legislative movement, was the first international declaration from a multilateral organization in the world. That is very important. Some other issues, some other steps is, for example, in this year, this committee, the Organization of American States, in August, approved the second advanced report about international principles about neural rights. That principles maybe, probably, will be approved in the next session of this committee in March of the next year. And for that reason, is very important to put the eyes in this process. And finally, in the 2 months ago, and no, 1 month ago, in October, the Human Rights Council approved a resolution about neurotechnology and human rights. And I understand Milena Costas is in the next panel. Milena Costas was participated in the advisory committee of the Human Rights Council, and she prepared the proposal for Human Rights Council, and their contribution was very important. That's the evolution. But my idea in this evolution is express the importance of the Latin American in the construction of the international agenda in the neural rights standards. Latin America have a great opportunity to contribute to make international regulations in the Organization of American States, and in this way contribute to with other organizations like UNESCO. As I know, UNESCO have plans to advance in the international regulation in the IBC, International Bioethics Committee, and I put the eyes too in this process. Maybe this process will be very important for the international agenda.
Moises, by the way, Moises, sorry, your English is great. You don't have to worry about it. You're doing a great job in English. And but we are you're already has spent more than 10 minutes. So if you could finish your comments, then we can go to Guido and then Carlos, and then we have a Q&A with everyone.
Yeah. Okay. Thank you, Rafa. Finally, only express the importance of the national level. Chile is the first law in the about neural rights in the world, but Mexico, for example, approved international charter about national charter about persona digital person, and digital person.
Solo la hoja de solicitud.
Mexico is a very important actor in our region, and we have many times at the final of the panel, we can talk about the importance from the Mexico importance in our regional agenda and their contribution for strength the conversation about neural rights. Thank you, Rafa, and thank you, the Neuro Rights Foundation.
Thank you, Moises. I don't think you have to worry about your English. You're perfectly fine. Congratulations. Let's now pick up on what you left. As you mentioned, Chile, we have a panel in Chile because two things have happened there, which have been pioneering the world. The first thing is a constitutional amendment to the Article 19 of the existing constitution, which protects brain activity, cerebral activity, and the information that comes from it. So this is the first time that anything like this has ever happened, providing human rights level protection for brain activity and its information. And the second thing is a bill of neuroprotection, or bill of law, that specifies and lands these issues of human rights and neurotechnology with the specifics of the Chilean legal code, and applies the medical code of Chile also to some of these issues. And this bill was discussed and approved by the Senate, and it's now in the discussions in the Chamber of Chile. So I should say that the person behind both things, the bill of law and the constitutional amendment, is Guido Girardi. And through his leadership and vision and stewardship, the constitutional amendment was approved unanimously by the Senate and the Chamber and signed into law by President Piñera last year. And we have the fortune of having Guido here. And Guido, I'm going to ask you questions in English. I'll translate them in Spanish. You give me the answer in Spanish, and I'll translate it back in English. But you have to be very brief with your answers because I will not remember everything that you said. So Guido, welcome, bienvenido. The first question is why Chile? ¿Por qué Chile empezó con todo esto?
Primero porque durante ya casi 12 años nosotros organizamos uno de los eventos más grandes de ciencia de Latinoamérica, que organizamos como Senado y Congreso Nacional, pero que agrupa a todas las universidades chilenas, públicas y privadas, a la Academia de Ciencia, agrupa también a los territorios, que son parte de la fundación del Congreso del Futuro, que yo presido.
Okay, so let me stop here. So the first reason is because for 12 years now, Chile has organized, the Senate of the Republic has organized a Conference of the Future, Congreso del Futuro, which takes place every January, and which incorporates all the universities in the country, the Academy of Science, and it's a place where important issues are discussed in public with the country. And Guido is actually the president of the foundation behind these events. Perdona, Guido, ya puedes seguir. Sí.
Y bueno, este Congreso Futuro invita todos los años a 100 de los principales intelectuales y pensadores del planeta. Han venido más de 40 premios Nobel. Ha venido Yuval Harari, Richard Dawkins, Michael Sandel. Han venido los principales científicos e intelectuales. Tenemos una alianza con la Fundación Nobel y tenemos una alianza con la revista Nature y Science, que son nuestros media partners en este proceso, y ya tenemos 3 millones de seguidores, de personas que siguen el Congreso todos los años en enero. Y tenemos más de 40,000 personas presenciales.
De acuerdo. So this conference has been a great success. 3 million people follow the meeting. 40,000 people have attended in person. 40 Nobel laureates have spoken every January. 100 people are invited to speak from all over the world. The Conference of the Future has a built-in alliance in cooperation with the Nobel Foundation and so with the Swedish Academy of Science, and the also with the Nature and Science scientific journals.
Y en este momento tenemos más de 1,000 científicos y científicas trabajando en proyectos estratégicos para Chile, como son inteligencia artificial, hidrógeno verde, modelar los futuros posibles, el fin del trabajo, sistema alimentario, salud del futuro, educación del futuro. Y eso es la idea de generar una manera distinta de políticas públicas, donde participamos con todas las universidades, la Academia de Ciencia y el Congreso para generar políticas públicas, pero con la participación de todas las universidades y todos los centros de pensamiento chilenos.
De acuerdo. So the purpose of this conference is to organize public policy with respect to science and medicine, together with all the universities of Chile, the National Academy of Science in Chile, and through this conference, they've launched over 1,000 scientific projects in Chile then carried out by Chilean scientists that involve from green energies, hydrogen, climate, AI, so all kinds of frontier issues, so future issues, hence the name. Perdona, Guido, ya puedes seguir.
Y en una de estas reuniones del Congreso Futuro invitamos a Rafael Yuste. Hace muchos años atrás lo llevamos a la Antártica, se dedicó a buscar hidras, pero en ese viaje fuimos reflexionando sobre los impactos que estaba teniendo la inteligencia artificial, particularmente en nuestros cerebros. Y a partir de esas conversaciones con Rafael que se iniciaron en la Antártica, y luego culminaron en el desierto de Atacama, en los extremos polares de Chile. Una fue en el extremo sur, en la Antártica, y la otra en el lugar más frío del planeta, y la otra fue en el lugar más caliente del planeta, en el otro extremo, en el desierto más seco del planeta, donde íbamos a subir a Alma, a visitar Alma, y Rafael nos había convencido que era un gran caminante, un gran alpinista,
All right.
pero
Stop it for a
lamentablemente
second.
no pudo subir a Alma porque tenía la presión alta. Bueno, ahí como compensación le propusimos hacer esta idea de generar en Chile la primera aventura para proteger los cerebros.
Okay, so stop it here. Perdona. So as a consequence of one of these conferences, they invited Rafael Yuste, which happens to be me, and and they took the speakers to different parts of the Chilean geography, from the Antarctica Peninsula, the Chilean bases there, all the way to the north to the Atacama Desert to see the international observatories, ALMA. And in this meeting, they started discussing with me the impact that AI and neurotechnology could have in the brain and in humans. And that's a consequence of this meeting, in a brainstorming session in the desert in Atacama, we discussed the possibility of having a pilot project in Chile for neurotechnology, as a regulation of neurotechnology. Sigue ya, Guido.
Bueno, nosotros tenemos la convicción de que el mundo cambió y que la geopolítica del siglo XXI va a estar concentrada en los cerebros de los seres humanos. Que el poder del futuro es la inteligencia artificial, y el poder del futuro se construye con datos, y se construye interviniendo el cerebro. Por lo tanto, los pozos petroleros del futuro, donde se extrae el poder, que en el pasado fue el petróleo, hoy día es el cerebro. Y es el cerebro, hoy día es lo que está más expuesto. Y por lo tanto, nosotros tenemos responsabilidad de, dado que ahí se va a dar la lucha del futuro, ahí va a estar la disputa política, la disputa económica del futuro y la disputa geopolítica del futuro. Por lo tanto, nos parece que para resguardar el desarrollo de la ciencia y la tecnología, pero al mismo tiempo proteger los derechos humanos fundamentales, nos pareció que era muy importante establecer un nuevo derecho humano, que es los neuroderechos.
Thank you, Guido. So the senator said that they are convinced that in this world that we live in, the new commodity, the new oil, so to speak, are data and brain data. That with the progress of AI and neurotechnology, we're entering a new phase in a new industrial revolution, a new phase in our history. And at the same time, brain data and brain activity is not at all protected. So he thinks it's a very risky situation where the new source of richness is going to be data that comes from the brain, and at the same time that has no protection. So that's why they were interested in pursuing a human rights approach to the problem. Guido, una pregunta. ¿Cómo fue? ¿Hubo consenso interno en Chile o tuvisteis problemas para avanzar con esta idea?
Bueno, en Chile, justamente porque el Congreso Futuro une a la izquierda y a la derecha, une a ateos como yo y a católicos, como ahí está Carlos Amunátegui, por ejemplo, de la Universidad Católica, une a universidades públicas y privadas, y como la izquierda y la derecha no tienen respuesta respecto al mundo que viene, tienen respuestas para el pasado, pero no para el futuro, fue posible construir un gran consenso. Y una cosa inédita, tal vez es de los pocos proyectos, estamos hablando de una reforma constitucional que normalmente tiene una discusión extrema, además modificaba el artículo 1, o sea, el artículo que tenía que ver en la reforma constitucional con los derechos humanos, que era una acción temeraria desde el punto de vista del desafío. La paradoja es que fue aprobada unánimemente. Y yo creo que eso habla también de la manera en que se hacen las cosas. Cuando uno construye alianzas.
Yeah, gracias, Guido. So the question is, how was the process of developing this constitutional amendment and the Bill of Law? If there was a lot of opposition, or if it was complicated, and his answer is that there was wide consensus that both the right wing and the left wing, the right political parties and the left political parties were in complete agreement, because according to him, they look to try to explain the past, not at the future, and they have no idea what's coming in the future. So everyone sort of was equally ignorant about the future. Senator Girardi also said that because the Congress of the Future involves a wide spectrum of the Chilean society, again, all the universities, the Academy of Science, this enabled to obtain very quick wide support for these ideas. And a proof of how beautiful this was that something like a constitutional amendment, which normally you would think would take a lot of heavy lifting and debate, particularly with respect to human rights and some of the most basic points in the constitution of a country's issues of human rights. In this case, it led to unanimous support by the entire Senate and the chamber. So this is a proof that the Chilean process was apolitical, was transversal. It involved all parts of Chilean society, and it's, according to the senator, a beautiful example of the building consensus. So Guido, we're going to switch now. Vamos a cambiar to let Carlos the opportunity of speaking, but we'll come back to you. Please don't disconnect. So Carlos, you are okay talking in English, I presume. I've heard you speak well in international forums. So just a question for you as an expert in some of these issues that are being discussed. How do you see the Chilean process? What do you think will happen with the constitutional amendment, with the Bill of Law, and what are the pros and cons of these issues when we look at the future? And the floor is yours, Carlos. Yeah.
Okay, thank you, Rafael. Well, really, I'll do my best to speak English in a kind of
I can help you if you need help.
intelligible way. So let's start. Well, fortunately, in the morning there were quite interesting expositions about neurotechnologies, about the ethical implications, about the human rights issues. So fortunately, I do not have to go into that. I can assume everybody is somewhat aware of it. So the main question, I think, for me is why do we regulate at this point? Because this is quite a debate. When is it a good moment to regulate a technology? And in particular, why are we regulating so early this very important, this very relevant technology as neurotechnologies? Well, these are technologies of biblical proportions. They can make the deaf hear, the blind see, and the paralytic walk. So it's as close as you can get to a biblical technology. So why do we regulate it so early on? Because, you know, from my point of view, at least there are three important issues that we should face. First, if we want to develop a well-functioning market of neurotechnologies where people can participate without a bias, with a protection of the privacy of the data, with a proper protection of their individuality, I think the only moment to regulate this market is now. These markets are not natural. This kind of left-right confrontation about state or about markets or regulation, it's really a fallacy. Markets need regulation, every market. Would we have, for example, a real estate market if there was no regulation on the sales, on the contract of sales, on money, on banking, on real estate? A market supposes regulation. You want to develop a market, you need regulation. The second thing is that if you just let the technologies emerge without any kind of regulation, you could have a big damage that it's not easily reversible. Maybe paying for the damage will be much more expensive than the small reduction in the profits that you can get if you prevent the damages. This is like the contradiction. If we're going to put it in medical terms, what's better, to have a vaccine or to have a treatment, therapeutic treatment? Then, if you regulate the market in a proper way, with safeguards, it's easier also for the companies that are developing neurotechnologies to participate in doing the correct compliance of the legal regulation. One of the main problems for companies is in a new market is that they have no way of knowing if they are doing a proper compliance with the ethical and legal standards. If you give a good law, a good bill, this will be overcome. So I think it's really a very important thing to do it. Why do it in Chile? Well, we are kind of a regulatory sandbox of the world. Many regulatory experiments have happened in Chile. Well, this is a very good one. I'm glad to participate in it. And what are the main points of our regulation? The regulation we are proposing in Chile. Well, you know, the constitutional reform was approved unanimously in the Chilean Congress. This is quite unique. You know, Chile is a deeply divided country in the political arena. as divided as, for example, the United States. So this is quite a feat, in my view, Rafael and his expertise. It's quite a feat to get this kind of divided country to vote all the political spectrum, from the communists to the right wing, everybody voting for one constitutional amendment. The bill proposal was also unanimously approved in the Senate, and I think it's going to be swiftly approved also in the in the House of Representatives. Which are the main points of our regulation? Well, we distinguish. Well, we want to regulate not the technology, but the uses of it. We are adopting a medical paradigm to regulate the whole of the technology. We believe neurotechnologies should be submitted to a process of registration in our Instituto de Salud Pública now, an organism similar in a way to the FDI. We distinguish and we regulate accordingly to the use that we're going to do with the technology. For example, therapeutic uses of neurotechnologies are regulated with the common legal framework of medical practice. We have nothing new to say about it. Same on research. In fact, both laws of medical therapies and research, they were approved quite recently. The main focus of this regulation is consumers. This is kind of the main focus. Although we give a common framework for any neurotechnology, we are focusing more strictly on consumers, because that's the area that's really not covered. We put some common framework for any neurotechnology to be used in Chile. For instance, for example, we demand that consumers, the neurotechnologies applied to consumers are reversible. We demand also in the bill proposal that the consent must be expressed, must be detailed. The person must consent not only to the neurotechnology, but also to the use of the data obtained by it. We put some uses that we prohibited. We forbid some certain uses of neurotechnologies. The heart of these prohibitions are taken from the bill, from the regulation proposal of artificial intelligence of the European Union, quite parallel really. For example, we forbid the use of the neurotechnologies to influence conduct without knowledge of the subject. We prohibit also neurotechnologies that exploit a person's weaknesses. We also prohibit the stealing of data, obtaining data surreptitiously. And of course, we forbid uses that might affect neuroplasticity. We also put a framework of strict liability to the damage that's done to consumers. And going to Professor McKay's question, we also treat the problem of when you make someone commit a crime, for instance, using a neurotechnology. We give a special excuse for the person that commits the crime because it's not really liable for it. And we put a special crime on the person that uses another one. So he would be unemployed. So this is kind of the main framework. I don't want to take too long because I think the richness of these presentations are going to be in the discussions.
Thank you, Carlos. You did an excellent job. And again, congratulations on your English. You don't have to worry at all. You're so clear. I love also your term sandbox. You said that Chile is like a sandbox. This is a wonderful way to describe why Chile. And following up on that, I wanted to ask Senator Girardi, following on the idea of the sandbox, because this is not the first time that Chile is pioneering international regulation. And it happens to be Senator Girardi, the same person that we have here, who pioneer also the regulation of high caloric content food in Chile. So, Guido, ¿puedes responder a una pregunta? ¿Puedes contarnos que estuviste detrás de la ley de etiquetado y que esto demuestra que Chile también ha servido como laboratorio de leyes que han sido adoptadas internacionales? ¿Puedes resumir brevemente qué es la ley de etiquetado y cómo surgió y qué repercusión ha tenido internacional? Pero tiene que ser muy breve porque te tengo que traducir.
Bueno, primero, la mayor pandemia que enfrenta la humanidad es la obesidad. Mata más que el COVID, pero es silenciosa porque es un gran negocio para las transnacionales de la comida basura y para los laboratorios.
Espera ahí. The biggest pandemic of the humanity is not COVID, it's obesity. Kills more people than COVID and all the epidemics together. And the reason it's not stopped is because it's a big business for international, multinational companies. Ya, sigue.
Y nosotros siempre hemos trabajado con la Academia de Ciencias, y en el año 87, junto a un Premio Nacional de Ciencia, Ricardo Huawi, decidimos enfrentar y buscar un instrumento para lograr prevenir la obesidad en el mundo, que es responsable de los cánceres, de los infartos al corazón, de la hipertensión y la diabetes.
Stop here. In 1980s, perdona,
90, en el año 2007.
In 2007, we worked together with the Academy of Science and with the one winner of the National Award for Science, Ricardo Huawi, to tackle this epidemic of obesity, which is again is responsible for it's underlying a lot of the cardiovascular hypertension and stroke, among other, and diabetes. I have to mention that Senator Girardi is actually an MD, he's a medical professional. Sigue, Guido.
Lo primero es que estas enfermedades tan mal llamadas, mal denominadas, son una fake news, tan mal llamadas enfermedades crónicas no transmisibles. Eso es una concesión, es una vergüenza que todavía la Organización Mundial de la Salud las defina como enfermedades crónicas no transmisibles porque son las más transmisibles de todas, pero se transmiten a través de la publicidad, son transmisiones meméticas.
So he's saying that all these diseases that are normally defined as chronic non-transmissible diseases, this is actually fake news, even though it's defined like that by the OMS, the organization of the World Health Organization. These are the diseases that are transmitted through advertising, through publicity, and they lead to different change in lifestyle that, in the case of obesity, that underlies all these secondary medical conditions. Yeah.
Y lo primero que hicimos nosotros es establecer el derecho a saber. Hay una violación de derechos humanos a los niños, a las niñas y a la población, porque yo tengo acá un cereal americano muy comido, muy famoso en Estados Unidos. Ese es el etiquetado, ese etiquetado no lo entiende nadie. Está hecho para que nadie lo entienda. Sí. Esto es un engaño porque permite poner basura dentro de un envase que parece saludable, que tiene animaciones, que tiene juegos. ¿Quién entiende esto? Yo no lo entiendo.
So the first right is the right to know. So he's demonstrating that this cereal box of has a label that no one understands, and in fact, it's designed so that no one understands what the label says, the health label, and it's all dressed in this very appealing a form with these cartoon characters to make it very likable by children. At the same time, the important information, the health information, is incomprehensible. Sí,
Entonces, lo que hicimos fue poner estos sellos, que puede ser alto en azúcar, alto en sal, alto en grasa y alto en caloría, que un niño de 6 años puede ya saber. A los 6 años ya puede distinguir que esto es basura.
So what they did is they made companies label these boxes with these black labels that says high in saturated fat, high in sugar, high in calories. And these are very simple, distinct black labels that even a 6-year-old can understand and recognize immediately that this could be risky to eat.
Y no basta que tenga uno, como es basura, basta que tenga un sello, como es basura, no es saludable, no puede tener publicidad en la televisión.
Yeah, if there's only one of these black labels, that means that it's junk food, it's not healthy, and it should not be advertised in TV or radio.
No puede tener animaciones.
It cannot have cartoons, or it cannot.
En Chile no se puede vender el Kinder Sorpresa.
In Chile, you cannot buy the Kinder Surprise Kinder.
No se puede vender en colegios.
You cannot sell it in schools.
No puede haber compras públicas del Estado.
The state cannot use public funding to purchase these items that are unhealthy.
Pero si la empresa se transforma en una empresa que deja de matar la gente y de destruir la vida y baja los sellos, elimina los sellos porque baja la sal, la grasa, el azúcar, puede recuperar el derecho a tener publicidad y a tener animaciones y a vender en colegio y a tener compras públicas.
So companies can recover all this right to advertise the product in TV, to sell them in schools, and to have the public funds being used to purchase them, as long as they lower the sugar, the calories, or the salt in their products and make them healthy. So there's a way for companies to comply with this regulation and go back to a situation where they're not, they can sell their products freely. Yeah.
Y en Chile ha bajado ya en un 25% el consumo de bebidas dulces como Coca-Cola y otras, y ha disminuido en un 25% la venta de cereales con azúcar, altos en azúcar, como cereales Nestlé o como cereales de los que se venden en Chile.
So in Chile, thanks to this law, in Chile, there's been a 25% decrease in the sale of high caloric drinks, and a 25% decrease in the sales of cereals that have these high caloric or sugar or salt.
Pero lo más importante es que el 25% de todos los productos son reformulados. La industria ha reformulado para hacer saludable el 25% de todos sus productos de alimentación.
But what's more important is that 25% of all the food products in Chile have been reformulated to make them healthier for the population. Guido, con respecto al impacto que ha tenido esta ley en el mundo, ¿qué puedes decir de una manera resumida?
Bueno, que esta ley la llevamos a Perú, la aprobamos en Perú. Tocó muchas veces apoyar al Parlamento peruano, la aprobamos en Argentina, la aprobamos en Colombia, la aprobamos en Uruguay, la aprobamos en México, y ya hay cerca de 30 países que están siguiendo el modelo. Yo he estado en más de 30 países en estos últimos 4 años promoviendo esta ley, invitado por la Organización Mundial de la Salud. Además, la FAO, Naciones Unidas, nos dio un premio, el premio más importante que da Naciones Unidas, por esta ley, y FAO la tomó como su modelo mundial para prevenir la obesidad.
So Guido says that besides Chile, they pioneered these similar laws in other countries in Latin America. And there's now over 30 countries that have adopted similar legislation. And in fact, the World Health Organization has sponsored this law and proposes this as an example to follow to other countries. And as consequences of that, Dasenaro Gidardi received the prize from the UN for his pioneering work in terms of defending this type of legislation approach to healthier food. Muchas gracias, Guido.
Pero, Rafael, este cereal es uno de los más consumidos en Estados Unidos y
Yes.
tiene 3 sellos, tiene cerca de 40% de azúcar y 600 miligramos de sal. Esto es criminal, esto es una vergüenza que en un país que se dice desarrollado se permita vender esta basura con publicidad engañosa, engañando a los niños y atentando contra su salud actual y futura.
De acuerdo, Guido. So Guido is saying that this particular cereal is an example of something that shouldn't be happening. It has over 40% sugar content, over 600 milligrams of salt. And this is just junk food that is being sold, and it blemishes the reputation of the U.S. as a leading country in the civilization of the world, that this should not be happening. And now we're going to ask maybe Moises a question from the chat. I encourage our viewers to type questions. You can type them in English or in Spanish if you want, and we'll translate them. Question from Marta Sosa. What are the implications of the rejection of the constitutional reform on the Article 19 for the adoption of or the draft bill on neuroprotection?
I think I can answer this one. Okay, what was rejected? Yeah. What was rejected was not the Article 19 #1. No, it was what was rejected was the project of new constitution for Chile. The constitutional reform was made before this process probably started. So the constitution that is now in force in Chile has the protection of neuro rights. The project that was rejected in the plebiscitum, well, is simply it's a project of a new constitution. I hope it's much wider than the neuro law, the neuro rights protection bill that we are working on. And well, probably there's going to be a new constitution in Chile anyway in the near future, and we're quite sure it's going to contemplate neuro rights again because, well, the political spectrum is for it. It's one of the few things where all Chileans in agreement.
So Carlos Ome says, so for those of us who are not Chilean and don't know the Chilean process, what will likely happen in the future with respect to the constitution and the incorporation of neuro rights in future constitution?
Nowadays, at this moment, we have neuro rights in the Chilean constitution. This is law. This is in the constitution that it's in force. In the future constitution, it's probably going to be contemplated also, because there are two main arguments. The first one is that everybody, the whole political spectrum is for having neuro rights in the constitution. And the second thing is that there's quite an old doctrine in the Corte Interamericana de Derechos Humanos that says that you cannot go back in human rights. Once you state a human right in one text, you cannot go back and take it out in the next one. So this is kind of important.
Mm-hmm. Moises, what are your thoughts about the future of human rights for neuroprotection in Chile, and also with respect to the neuroprotection bill, which is still being debated in the House?
As Carlos says, the neuroright law, constitutional reform is actually in vigor. I have 3 ideas for your audience about the next step. The first idea is at international level, maybe we need support the effort to the Human Rights Council. It's very important. When the Human Rights Council approved the resolution in October, that approve is put formally the neuro rights in the UN agenda. Second, at regional level, it's very important promote the Inter-American principles of neurotechnologies and human rights in the Inter-American Juridical Committee. In March, this committee have the next meeting, and it's necessary the support of the civil society, of the private sector, with compromise with the standards and other actors. And in the third way, it's very at the local level. The Mexican process will be very important for the international debate. In the December 1st, they released the Bill of Rights of the Digital Person in Mexico. This Bill of Rights have a chapter about neuro rights, and we talk with the promoters about this bill, and they are agreed in order to make a process similar to the Chilean process, with senators, with politicians, with the public bodies. And it's very important have the support of the Neuro Rights Foundation, of the Guido, the former Chilean Senator Guido Girardi, and make Mexico the new Chilean in this agenda. With 3 ideas, I can express my greetings with Senator Girardi and you, Rafa, for your effort for promote the Chilean reform. This reform was very important for the region and very important for the world.
Thank you, Moises, and thank you, Carlos, and thank you, Guido, for your participation here. So this is very exciting. I think this country that you live in, the sandbox of the world in terms of our legislation for protection of consumers or citizens, again, has proven its value already with, as the senator explained, with the high caloric content food and the labeling law, which is being copied all over the world. And again, it's a tribute to your country and since I know Chile and the culture, I think I have to express my admiration for your country and the people in your country that share this spirit, indomitable spirit, that are brave people, and they go where no other person has gone before, and that is not surprising since you are at the very tip of the edge of the continent, the last bit of the continent to be explored, and after having seen also the Chilean Antarctica and the deserts in the north, the resilience of the Chilean people, and honestly not surprised that it happens to be Chile, the country that is behind a lot of these issues with not just with the labeling law for food, but also with neurotechnology. So anyway, so with my thanks to your work and admiration for your country, we're now going to finish this panel, and we will go on to the last panel, which will follow exactly on the comments that you have been making about the involvement of the UN. And we're going to discuss this right on. And with this, I'll pass the torch to my colleague, Jared Genser, who's going to be moderating the panel and giving me a well-necessary break. Thank you all. And Jared, the floor is yours now. Thank
you. Hello, everyone. I need to get my video working here. Let's see how, make sure we get everybody on here for this panel. Here I am. And is Edgar here? And then also.
Yes, I'm here.
I'm here, just struggling with the video.
Okay.
And I think we're missing Milena. No, she was here earlier, but she's not here right now.
Yeah.
I'll send her an email, but why don't you get started? Yeah.
Okay, let's get started. Good afternoon, everyone, and good to see you again. I am Jared Genser, an international human rights lawyer based in Washington. We've got a really interesting panel to talk about neurotechnology and human rights in a operational sense. Up until now, we've obviously talked about neuro rights more broadly and neurotechnology as well, with greater specificity in how it's developing. We've now seen a case study at the national level in Chile. And here we're going to kind of step back and have a wider frame and look at the role of the United Nations in advancing neuro rights in a wide array of contexts and a wide array of ways. We've got a great panel. My colleague Stephanie Herman is running point at my law firm on all the things that we're doing with the Neuro Rights Foundation, and she's here to discuss a major report that we published with the Neuro Rights Foundation earlier this year about, which is an international human rights gap analysis, looking at international human rights treaties and how neuro rights might be protected within that existing international legal framework. We also have with us as well Edgar Corzo Sosa, who is a brilliant and highly regarded Mexican human rights lawyer, and more importantly for present purposes, also has a very, very important role at the United Nations as the chairpersons of the treaty bodies at the UN in Geneva. This means that he is the chair, as he'll explain, of all the different treaty bodies that monitor implementation of each of the human rights treaties. And so we'll be coming to him as well shortly. Let me just begin by framing an overall approach that we're going to take here. Let me just right now see if I can share my screen briefly. Let's see, here we go. Yes, here we go. All right, so what you can now, I think, see on your screen is this was from a report that we did earlier this year, on human rights protection gaps in the age of neurotechnology. And what you can see here is that what we have proposed at the Neuro Rights Foundation, and this is just speaking for the Neuro Rights Foundation, there are a wide array of ways to try to protect and promote human rights and neuro rights within the UN system. And you can see here that we talked about the need for leadership, institutional architecture, and strategies. This looks at the different people that might be able to work on these issues. We were proposing potential architecture as well as potential strategies. I'm excited to report that a lot is already moving forward. And in fact, this chart from earlier this year has already been superseded by certain events. And I'll just note up front, just to frame these overall discussions, that the Office of the UN Secretary General, Antonio Guterres, has already been engaging on these issues. In fact, in his report, Our Common Agenda, which is the 5-year strategic plan for a second term as Secretary General, he talked about a critical area of concern being the human rights implications of neurotechnology, and he mentioned new technologies, and neurotechnology in particular was mentioned in that report as well. And he and his office have held 2 private meetings with a wide array of stakeholders to consult about these issues and to think about a way forward. We've already seen as well at the UN Human Rights Council. One of the things we talked about was the idea, you can see here, that the Human Rights Council should work towards a resolution. And in fact, you know, a short time ago, during its September session, the UN Human Rights Council, in fact, adopted a historic first resolution on the topic of neurotechnology and human rights. And that was and that resolution, which was recommended to be adopted, in fact, by the Advisory Committee of the Human Rights Council, has now commissioned the UN Human Rights Council's Advisory Committee to do a first ever study, comprehensive study on the issue of neurotechnology and human rights. So these are a wide array of developments that are already underway. And if Milena is able to rejoin us, then she'll be a very, very important contributor to this discussion because, in fact, she's the chair of the Advisory Committee of the Human Rights Council, which had proposed to the Human Rights Council that they be commissioned to, in fact, do this study. So hopefully we'll be able to be joined by her as well. I think that you know, perhaps we should begin with Edgar here, if that would work for you, Edgar. Because while my colleague Stephanie Herman will dive deep into the different treaties and you know, the different you know, UN human rights treaties that focus on human rights and the gaps that might exist and how they might be filled. As the chairperson of the chairs of the different human rights treaties at the UN Geneva, I thought you might be able to begin by providing a high-level view about the UN human rights treaty system, what that system actually is, what it's comprised of, the different kinds of treaties that are a part of it, and then speaking about your role as the chairperson of the chairs of these different treaties and how you see the topic of neurotechnology fitting into the work of the different treaty bodies and the coordination across treaty bodies.
Yeah, Jared, you gave me the floor?
Yes, please.
Thank you very much. Well, thanks. First of all, I would like to thank to Rafael for inviting me to be with you today. And of course, well, we had met both in 2 occasions. First, at the presentation of a special issue of the Constitutional Law Journal that I've been heading for more than 22 years. And the second one was because I visit the Columbia University, and I met with Rafael, and he showed me his laboratory, who was impressive. So I'm been listening to all of you. I can tell you that I completely immersed. I'm very up to date during this morning, and I would like also to give you my opinion and all what I think about this that you were just mentioning. Let me tell you first that I've been reading the Rafael, Stephanie, and yourself, the article you have written, and I can say that I agree with the approaches that you have made. This is very important, your approach. So I think that definitely it is important to find a way in which United Nations get involved in the issue of neuro rights. However, I would like to add some points of view based on the experience I have had as a member of a human rights committee and also as the chairman of the 10 human rights committees. In my opinion, let me tell you that I believe that certain principles should be taken into our consideration to guide our actions. For example, it is necessary to create national awareness, also make the issue visible, and of course, to approach the United Nations. These principles are based on a fundamental premise, which is that United Nations should take into account the issue of neuro rights. And I think that this can be done Of course, let me take my time. I forgot. Yeah, I'm ready. You can do that directly to the United Nations, seeking that the countries follow the guidelines issued by the United Nations itself, either as a declaration, as principles, as an international treaty or human rights, or something else. This is what I have read and heard from Rafael, Stephanie, and yourself. And it is a methodology that I could say it is very logical. However, another methodological approach is also possible, which comes from the bottom to up, from the nation's state to the United Nations. This is the way I would say most United Nations issues arise. First, they constitute a major problem of concern in a considerable number of countries, and then the concerns begin to be raised to the level of the United Nations. I think that in this new methodology, the principles I mentioned above may apply without problems. One principle is create national awareness. I think that it is important just to, the issue should be a concern in the states. I mean, the rights need to be a concern, a very important concern, so that there is a broad knowledge of what their rights are and what they have to be talked about. I'm afraid that this principle has not been generalized. There are countries that know what it is, but that is because they are doing research, or like Chile that we have heard just a few minutes ago, that they have involved in a very important constitutional amendment, and they continue doing work on this issue. But not other states are in the same level of immersion like Chile. So it is very important just to create national awareness. The second principle is making the issue visible. What do I mean by that? Well, here I wanted to point out that it's also important to disseminate the issue of their rights at the national level, but also at the regional and universal level. In this way, it could be very important to organize events in which the scope of their rights could be made known in different countries, which governments, but also with national human rights institutions, and also with civil society. It would be very important to go to different international forums related or not to human rights to talk about their subject. A meeting of heads of state, for instance, could be a very interesting forum to raise the issue. The crucial point here in this principle, I think, is to make noise, enough noise to bring attention and to make the issue of their rights very common. And the third one, which is the approach to the United Nations, which is the main issue that we are trying to deal with. This is the most complicated issue, of course. There is an original idea of outreach, knocking on the doors to get them to open and raising the issue, hoping that it will be understood and accepted. However, this way of acting is more about analysis, but not about the emergence of a problem to be solved. There is a difference, from my point of view, between these two expressions, especially from the impact that can be provoked with one or the other, and definitely seeing it as a problem accelerates its treatment. Within the United Nations, we must be clear about what we want to do and establish a series of steps that will lead us to the objective step by step. I agree, for instance, with the creation of a commission of experts of neural rights in consultation with treaty bodies and special procedures. Likewise, it is good that there should be advisors in this area who identify best practices and keep abreast of scientist developments, and who consult with key countries. I can say the same about the creation of international treaty or a protocol, or the adoption of general comments by the committees, or even the appointment of a rapporteur on neural rights, or the creation of a special agency of the United Nations. However, I believe that we need to create a need. And by that, I do not mean that we need to be told what neural rights are. I'm referring rather to the existence of various references that make it clear that the subject is of concern to the states, and some United Nations agencies have already made mention of them. but to say again that we are doing it from the inside and from above. Maybe it is worthwhile for us to look at it from the outside and from below, so taking preliminary steps so that in the end, this movement takes place within the United Nations. I'm thinking, for example, of organizing an event on human rights where the Office of the High Commissioner for Human Rights would be invited, or commissioning a study to a legal research institute and to disseminate the topic in different places. I remember that I recall that Rafael was talking about Inca paper. This is example. And we need also to look for all declarations already made that are related to neuro rights, like bioethical declarations. So we need to do some research, deep research about all what we can find in several declarations. Being more directly inside the United Nations, I consider that we should keep in mind two important instances: the Human Rights Council and the Office of the High Commissioner for Human Rights of the United Nations. As you know, the Human Rights Council is a group of 47 countries representing 5 regions of the world. Human rights rapporteurs, as well as working groups and other special procedures, are appointed by this council. In order for it to appoint a rapporteur or a working group on neuro rights, many steps are required. Since it is a body composed of states, several states are required to take the initiative to bring the issue before the Human Rights Council, including not only before the Council, but also before the General Assembly. So they are called champion states, co-facilitators state, or wherever, but they are the states that are committed to leading the neuro rights movement. So there is a need just to figure out which state would be the best state just to lead the effort, just to talk about neuro rights. Finally, we have the United Nations Human Rights Committees. I think there is no problem in trying to do something directly with some of the committees, depending on the scope of the international convention that governs it. You can be very imaginative and refer to the right to privacy or against torture, but also to the right to free development of personality or the right to mental health as well. However, it is worth asking ourselves whether the issue of human rights has to do with just a few committees or with the 10 human rights committees. In my view, it definitely has to do with all of them in one way or another. So why not try to obtain a declaration or a guiding principle on human rights that would be approved as a first step by the 10 committees? I think that it would be a great step toward and would constitute a reference within the United Nations. As for the rapporteurs and working groups, I believe that even before the creation of a special rapporteur on the subject, which is not easy and will certainly take a long time, a declaration could also be sought from one of these special procedures in order to create references that we can then use. These are some ideas that I wanted just to share with you. Thank you very much.
Thank you so much, Edgar, for the comprehensive approach that you took, as well as for your observations and comments. And it's fabulous to have you and Milena as insiders within the system, speaking about your observations and your experience, as well as your views as to where things might go from here. Before turning to Milena, I actually want to go to Stephanie first, because it relates to your most recent comments, Edgar, you were making about the role of UN treaty bodies. And so I want to kind of stick with UN treaty bodies as a topic and talk about that further first, and then we'll come back to Milena to talk about the Human Rights Council and the advisory committee to the Human Rights Council, which she chairs and in which she's already demonstrated extraordinary leadership in advancing the topic of neurotechnology for the first time in any meaningful way within the UN system. So let me first, however, turn over to my colleague, Stephanie Herman, who's a brilliant human rights lawyer and worked with Raphael and me on a first ever human rights gap analysis report that we undertook earlier this year to look at the existing international human rights treaties that exist, examine the risks associated with misuse and abuse of neurotechnology, and then looking at international treaties to understand, where are potential misuse and abuse of neurotechnology already protected against within existing international human rights treaties. How could interpretation of certain provisions be potentially expanded to cover potential misuse and abuse of neurotechnology? And then what gaps actually exist that might ultimately need to be filled through other kinds of mechanisms. So Stephanie, let me turn it over to you from here.
Thank you, Jared. And it's a pleasure to see you again, Milena, and it's great to meet you, Edgar. So essentially, this report, International Human Rights Protection Gaps in the Age of Neurotechnology, analyzes 7 of the 9 UN international human rights treaties. And as Jared mentioned, it looks at whether their provisions either currently protect neuro rights as they are articulated by the Morningside Group, whether those provisions could be broadly interpreted to protect neuro rights, and whether those provisions do not at all protect neuro rights. And what we've done in that scenario is we've actually proposed ways that the provision could be further interpreted, or ways in which the general comments, the official written interpretation of an article in a treaty, could be updated to reflect the neuro rights. And the goal of this analysis is really to help the UN find legally binding ways to protect neuro rights. So we heard earlier on the neuro rights panel about how once countries join an international human rights treaty, they have an obligation to bring their domestic national laws into conformity with their obligations under the treaty. And so the thinking is that by focusing on international human rights treaties, which are legally binding on the countries that join them, if those treaties contain an obligation to protect neuro rights, then it will make national regulation swifter and more effective, because that obligation will translate down from the treaty level to the national level as countries update their domestic laws. And so what we've done in systematically going through each of these treaties is we've examined not only how they affect the neuro rights, but also ways in which there are other potential violations or opportunities to advance human rights that come from neurotechnology that were not contemplated by the Morningside Group. So for instance, we discussed earlier the topic of informed consent. Broadly speaking, that's an issue that affects a person's sense of self or free will when engaging with neurotechnology, but it's not one of the officially enumerated neuro rights under the preliminary framework by the Morningside Group. And so we've taken care to include those ancillary issues in our analysis of the treaty provisions. So I'd also like to give a little context for why this report started at the UN. You've heard now from Jared about the size of the UN and its leadership ability in this area. You will hear from Milena about what's already happening at the UN, and from Edgar on the use of the treaty bodies. But I'd also just like to highlight that as international frameworks have already proliferated on the topic of neuro rights, there are a couple of reasons why the UN is better situated than those organizations to lead in this area. The first is that in existing frameworks, definitions are not centralized. That is, each framework that's come out has used a different definition of each of the 5 neuro rights. And because the UN is the site of where the international human rights law movement first began, it's well positioned to start definitions and create a centralized set of standards. The second reason is because, as Edgar was discussing, the UN provides something that other entities do not, which is treaty bodies, a set of specialized committees that assess how well international human rights treaties are implemented, and which in some cases actually provide a forum for individuals to be heard when states violate their rights. And so for those reasons, the UN has sort of an infrastructure for leading on this issue and ensuring its effective implementation. So as we go through this report, please bear in mind that there are additional human rights issues that may arise due to neurotechnology, but I'd like to provide a few key examples of ways that existing international human rights treaties could be updated to both better reflect the neuro rights and to provide legal protection, which most existing frameworks do not provide. For instance, the Universal Declaration is often referenced when we talk about neuro rights, and the Universal Declaration as a resolution is not legally binding in its entirety in the same way that an international human rights treaty is once a country ratifies it. Once a country joins an international human rights treaty, all of its provisions become legally binding. And so the goal here is to provide legal protection for the neuro rights, not simply declaratory or consensus-based protection. So for instance, one of the ways in which international human rights law will need to be updated is in ensuring that terms are broad enough to encompass the new concepts that come with neurotechnology. For instance, in the general comments to the Convention on the Rights for Persons with Disabilities, there is mandated access to what are called assistive technologies. And so assistive is a term that we've considered in the report as broad enough to encompass neurotechnology. If neurotechnology is deemed to be one of the primary ways that people with disabilities are able to communicate or able to move, then that would certainly fall under the protections of the CRPD, and there would be a mandatory right of access that would be legally protected. However, under the International Covenant on Civil and Political Rights, and we heard some about that earlier today, there are some definitions that are missing that make it really hard to offer robust legal protection to the neuro rights. For instance, Article 18 of the ICCPR, which protects freedom of thought, conscience, and belief, does not define conscience. Arguably, it does not define thought. And while those are burgeoning philosophical questions, as Sarah Goering mentioned this morning, those are also legal questions, because it's very difficult to protect a right of mental privacy simply from inferring that from the existing text. Mental privacy may seem to go hand in hand with protecting freedom of thought, but articulating how a state can violate that right is really what's at play when we're talking about international human rights. And so I'll just briefly go through some of the major findings of this report. Ultimately, we find that the existing body of international human rights treaties, general comments or written interpretations of their provisions, and jurisprudence, the cases by individuals against states, are all ill-equipped to protect the neuro rights, and certain changes must be made, and the law must be further interpreted and evolve to be able to fully protect the neuro rights. Additionally, we find that the best protected neuro right under the state of international human rights law today is the right to agency, followed by freedom from algorithmic bias. The neuro right to agency is at least somewhat protected under the language of the ICCPR, the Convention Against Torture, called the CAT, the International Covenant on Economic, Social, and Cultural Rights, the ICESCR, and the Convention on the Rights of the Child, the CRC. That is, the language of multiple provisions in those treaties is broadly crafted so that it encompasses the idea of your sense of free will and your ability to make decisions under international law. Additionally, because of the AI revolution and the proliferation of AI frameworks in international law, there's already language in some of these interpretations and broadly circulating at the UN that addresses the issue of discrimination that could arise from algorithmic bias. And so that's not really a new concept necessarily. Yet we also find that the worst protected right is the neuro right to identity. And although the interpretations of the ICCPR, the CRPD, the Convention on the Elimination of Racial Discrimination, CERD, and CRC reckon with the idea of identity formation and retention, there's very little language available that describes the process of forming and retaining an identity. And so we'd like to see more robust text in the interpretation of these treaty provisions so that there can be a legally binding right of identity in the age of neurotechnology. So I'll stop there so we can pass things on to Milena. But those are the high-level findings of our report. Again, the link is in the chat. And I would also just like to mention, draw some attention to the main accomplishment in light of Milena's participation in this conference, which is that the UN Human Rights Council recently adopted a resolution that calls for the UN's first study on neurotechnology. The Neuro Rights Foundation, alongside others, had the honor of serving as an expert organization consulted as the Human Rights Council's advisory committee, which Milena chairs, was creating the proposal and the draft resolution text. So I just wanted to say thank you again to Milena, and we're so proud to have participated in a small way in that achievement.
Thanks so much, Stephanie. That was a perfect time to hand it to Milena. She is a pioneer within the UN system, having first, as chair of the advisory committee, prompted the committee to have a discussion on the very topic of neurotechnology and human rights, and then to propose and adopt a proposal. recommending that the Human Rights Council adopt a resolution on the topic, and that the advisory committee be commissioned to do a study on all this. And at the last session of the Human Rights Council in September, October, this historic resolution was adopted by the Human Rights Council by consensus. And now she has the tough job of taking this entire field of endeavor and facilitating a process where the advisory committee will receive lots of input from many different directions and ultimately prepare a highly detailed report. She's a brilliant human rights lawyer from Spain by background, and I'm delighted to turn it over to Milena to help everyone watching today understand a little bit better about what the advisory committee actually is, what the what role it plays with the Human Rights Council, and how you see this topic being addressed within the UN human rights system more broadly. Oh, we can't hear. I'm not sure. Whoever's, can you? We can't hear you. Let's see. Does someone have her phone? Does someone have her call number to, oh wait, you're on mute right now, Milena. Let's see. Let's see.
Now?
Yep, now we can hear you, yeah.
Ah, great. Thank you very much. And my apologies for not having headphones. So it was quite a mess, but thank you very much. And thank you for the patience. Great. And also let me thank you for the invitation and also for the great report you have done and the work you have done on from the Neuro Rights Foundation that I read with a lot of attention, and it's really useful. So first of all, I would like to say that this kind of meetings are super useful. I'm very happy to be in this panel with this high-level panelists, of course, and I think this is very important meeting in order to bring all different perspectives that from scientists, technologists, lawyers, etc., in order to be able to construct or to have a better understanding of this matrix and also to provide the responses. So I'm very glad also to hear Edgar, the presentation he has provided, which has already given quite a lot of possibilities within the UN system. But of course, as you mentioned, I'm here in my capacity of member of the advisory committee. And as such, I would like to start by giving a very brief overview of what are we doing and the genesis of this mandate, in order for the audience to understand better what is our mandate, and also how better to collaborate with us, because of course we have 2 years now to produce this report, the advisory committee, and I think we cannot allow ourselves to work alone in isolation. This is a very complex topic, and of course every kind of support or collaboration or input is very welcome. Well, the advisory committee was established in 2008, and we started, the first meeting was in 2008, and replaced the former subcommission on the promotion and protection of human rights. And it is considered this very big word, which is the think tank of the Human Rights Council, and the main role is to provide expertise and advice in the human rights issues. It is made up of 18 independent experts, which means that we are not UN employees, and that means also that we are working pro bono. Even if we are nominated by states and also of our nationality, and we are appointed by the council, of course we commit ourselves to work independently and committed to work for the progress of the human rights cause. Our committee holds 2 public sessions during the year, one in August and another in February. And these, of course, are open sessions where we can have NGOs and public academics attending the sessions. And during these sessions, we discuss the different mandates we have. As I said, our main activity consists in producing studies at the request of the Human Rights Council, that, as you know, it's an intergovernmental body, so it's made by states, and the diplomats are those which sit in this body. Nevertheless, the body is committed as well, and the mandate of the Human Rights Council is to work for the promotion and the protection of human rights. That means that we are all together working for the progression or progress of human rights. Our committee works at the request of the Council. That's important. That's why we need a resolution in order to produce a study. And also the members of the advisory committee, we can also submit research proposals, that is, topics that we think that the Council should study or should address or should discuss, because we think that they are of particular interest. And this is what happens with the study that we are now developing in relation with the neurotechnology. This comes specifically, as it was mentioned by Moises, from an idea that I have reading the newspaper, honestly, a Spanish newspaper, an article that appealed me, because it was, the title was, "We need a universal declaration on neuro rights." So this appealed me, and I thought this is a very good topic to bring to the advisory committee. And of course, it was endorsed by my committee, and we submit the proposal to the Human Rights Council in our session of August 2022. And we were lucky because we had a core of states, 4 states, a core group of states, namely Greece, Chile, Singapore, and Switzerland, who offered themselves to undertake this proposal and negotiate and submit a draft resolution for the session of the Council, which took place in between past September and October. And the resolution was very well negotiated, I need to say, under the leadership of Greece, because they proposed a kind of very formal and procedural resolution asking for a mandate for the advisory committee to develop a study on this topic. We now have this mandate, and we have to produce this report that will be presented in September 2024. Just, I don't know if we have a lot of time. I have some ideas on the negotiation of the resolution, but just to say that the proposal had a very good support from many countries. We have finally like 50 sponsors from various regions, and obviously very different sizes. For example, we have the support of sponsorship of US, France, Germany, Bolivia, Palestine, to give you an example. And well, I need to say, if we examine the different sponsors, they are mainly coming from the WELC, the Occidental Group, Europe Occidental Group, and also the GRULAC, the Latin American and Caribbean. We have also some sponsors from Asia, Eastern Europe, and in less number of African countries. As mentioned, the resolution was adopted on the 6th of October by consensus, which is very important. And it asked the advisory committee to prepare a study, and I'm reading literally, on impacts, opportunities, and challenges of neurotechnology with regard to the promotion and protection of all human rights, and ask also the committee, advisory committee, to make recommendations, action-oriented recommendations on how to address these challenges, opportunities, and of course, how to cover the gaps. It is important, as it has been said, that the Council adopted a specific resolution. This was not a topic that was included as, passing by in the resolution, appointing or extending the mandate of a special rapporteur. And that, for me, gives the idea that the Council has seen the challenge of this topic, and also has an intention of including and following up this topic as part of the agenda of the Council. Just briefly, how we are going to develop this study and how people or organizations can collaborate with us. Usually we establish a drafting group when we have a request for a study, and we will appoint a rapporteur and the chair of this group. Then we will elaborate a questionnaire that will be distributed in order to obtain inputs from states, and this includes other stakeholders. And of course, that means not only UN mechanisms like special rapporteurs, but also national human rights institutions, academia, and also NGOs. And we used to send the questionnaire to a mailing list that is made by the Secretariat, but of course, also the questionnaire will be posted in the website, so any organization that might have an interest in responding will be able to do that. We will process all this information, and we will produce a first draft in the middle term, I think, after 1 year, and then this will be discussed, obviously, in the public sessions that we will have in the coming years. As I said, we will also invite experts to give us insights on the subject, and as I'm doing now, we will attend the expert meetings, and we welcome any kind of organization that can bring us with food for thought. To conclude, just let me highlight why I think this report is important. First, I think it will foster definitely the understanding of states on the human rights implications of this technology. This will be discussed in the public fora, in the main fora of human rights issues, which is the Human Rights Council, even if it's composed by 47 states, which are those that have the right to vote. The Human Rights Council is attended by all the states of the world. So this means that there is no discrimination in having information and reflecting and having inputs on this, or contributing to this process. And of course, it will help to identify the main regulatory gaps. It will stimulate public discussion. It will help states to identify what a specific action can be taken. And there goes the importance also of these recommendations that we will include, which are of policy-oriented actions. So I think, as Stephanie mentioned, this is very important also to bring together all efforts into these recommendations. And of course, because of that, I think it's very important that this report doesn't come from the scratch, but brings together all the work you have been done up to now, and of course, to contribute to establish which are the more suitable actions in order to ensure that the existing human rights framework provides the best protection to human freedom, integrity, and dignity, as we have been mentioning all during this day. And so just to summarize, I think we are at the very beginning of this process, and I guess this is going to be very exciting. And I hope that in the course of all this process, I will be or engaging with you, and I will be glad of doing so. So thank you very much. I don't know if you have any question, or I was not very specific, but more descriptive, but I'm happy to answer.
Yeah, so I mean, let me ask a couple of questions to each of you, and then I think we have one or two questions in the chat group as well. Thank you so much for that presentation, Milena. It was incredibly helpful, I think, and quite informative. One question I would have, both for you, Edgar, and for Milena, given your roles within the UN system, is how do you see the coordination across the different parts of the system? Because of course the system, is independent. The different parts of the system are independent from each other, and yet you're talking about the same topic, but in different contexts. And so how do you see, for example, your role in working with the Office of the UN High Commissioner for Human Rights and the new High Commissioner, who's been involved actually already in this topic? How do you see, coordinating with different parties within the UN system as you work to develop an overall approach to these questions? I'll come back to the question of dealing with states subsequently, but right now I'm interested to see how you all would think about the different parts within the system working with each other to have a coherent strategy for addressing these issues.
To both?
Edgar, yes.
Okay, let's start then. Thank you, Milena. Or if you want to go ahead, no problem.
No, after you.
Thank you, Milena. Well, I wanted to say that we are all the time coordinated. I gather information in all the committees, always gather all the informations provided by all the committees, even the information coming from the Human Rights Council. We have information also coming from the special procedures, also for the United, the periodical review. It's also, we gather information from that. And well, we are all the time sharing this information. As Stephanie said, well, we are issuing legal binding resolutions, our final comments with we are monitoring the states. So when we are monitoring one state, we gather all the information from different points of view. And if we wanted to make or to issue a general comment, then we also take advantage of a call for comments. We ask all the United Nations agencies and stakeholders also just to receive comments, just to receive or to have the feedback, just to have the general comments. So we are all the time, from my point of view, very coordinated, and we collaborate all the time.
Great. Milena, do you have something you might want to add to that?
Me? Yeah. Yes. Yes, thank you. I think it's a very good point, because one thing is as Edgar mentioned, the coordination in the interpretation and the standard setting, which I think it's clear as Edgar efforts underway, and this is very important that there is a coordination. And then there is also the coordination in between the different boxes and mechanisms within the structure, the UN system, which I think, it's the role of the High Commissioner, the Office of the High Commissioner, to bring all these, different elements into play. And indeed, one aspect I wanted to mention also in this relation is that in the resolution on the neurotechnologies, it is highlighted that we have to make recommendations on how these can be addressed in a coherent, holistic, inclusive, and action-oriented manner. So I think this was key, that this coherent manner terminology was included in this resolution, and I think it's our responsibility and the role of the advisory committee to study how effectively all the different mechanisms can work towards the protection of the rights, the human rights, in the case of neurotechnologies. So I think this is very important point, the coordination in between all. And as mentioned, Edgar mentioned before, there are many different ways to develop the interpretation. But I think the important thing is the coordination in the mandates, in between the mandates, and that we are not overlapping one with others, but at the same time we are taking the best of each one to produce something which is useful and necessary, I think, in this moment.
Jared, may I add something?
Please do.
Yes, I would like to say that if any committee want to elaborate a declaration, I think that we are obliged to, in the backgrounds of the statement, we mention all declarations made regarding the same issue. And there are not many issues regarding neurotechnological information. So this is, if you have that doubt, I will tell you that we will be very close. Just gather all the information and continue saying Human Rights Council or the Advisory Committee of the Human Rights Council already made a statement, and we will follow this statement and we will give another or further with another statement. Yeah, that's all.
Yeah. So let me ask you a related question, because again, there are people, a lot of people who are not necessarily experts on the human rights system watching this. How do you all deal with situations like the one we're talking about with neurotechnology, where there actually aren't really experts on neurotechnology, probably sitting on the UN treaty bodies or sitting on the Human Rights Advisory Committee, or even within UN agencies, because the field of neurotechnology is a very much of an expert field, and often people are academics at universities or working for governmental agencies or so forth. This is obviously a problem you have in many topics within the area of the law, where there are, especially let's say with emerging technologies. But how do you all think about being able in your consultations to draw on people who are actually experts in the field of neurotechnology, which is one key element of obviously your information gathering work that you have to do?
Yeah, now it's your turn. Milena,
well, yeah, I think it's not a great deal, but the only point is that it has to be an expert on human rights. Since I think this is the main issue. I mean, I couldn't dare to see myself developing neurotechnology. So I think the best way is that experts join efforts, and we work in a complementary way. Otherwise, I think we will continue to fragmentize, I think, the approaches. So I think since we have already a big background, and we have also the humus juris, no? The humus juris, we know the principles, we have an intuition on what, but I think also those doing technologies have this intuition. So it's not really that they cannot contribute to our work, on the opposite, on the contrary. But at the same time, I think it's, sometimes we don't have to complicate too much the things, and it's easier that we collaborate, that we listen, that we ask the right questions, that we go to look for this information, what is missing, and that we integrate this information in what we are producing. So I think the same from those working on technologies. They should be coming to us to pose the right questions in the right moment, to be present. And so I think it's more think of building bridges in between us, more than that replacing people with different interests in different places.
Let me just turn to the question of the role of member states of the UN in all of this, and member states of the Human Rights Council. Because Milena, you were right in the middle of all of these discussions, obviously first in the advisory committee and then with council members. And it'd be interesting to hear a little bit more. I'm obviously not asking you to attribute anything to any member states, but in the discussions you may have had with member states in general, what was the reaction within member states of the UN to this topic? I mean, how much awareness would you say there is of this topic and interest? I mean, again, there were a lot of co-sponsors, but I would imagine a lot of member states didn't have a lot of knowledge about this emerging field. So it'd be interesting to hear a little bit more about, again, not with specific names of countries, but just in general, how would you describe the range of views that you were hearing?
Yes, Edgar, I'm monopolizing the word in this.
Yeah.
Just yes, I mean, it was very interesting, honestly, the negotiations, the informals, the meeting where states have the possibility to make comments and proposals for this draft resolution. And honestly, I expected much more, how do you say, objections, but I didn't find them. I think the feeling was that this was very important topic, even if most of them, I mean, informally told me, okay, it looks like it's scary, but I don't understand really what we are talking about. So please, Milena, engage us in everything that you do, just for us to know. So I saw also within the diplomatic world a lot of interest, a lot of willingness of understanding. So I think that was very positive. And more than a refusal to address the topic, or I didn't see neither in the different regions a kind of objection, particular. Just I think it's not priority for them. But for example, the advisory committee, when I made the first proposal, we hold the meetings with the 5 regional groups, where I was presenting this research proposal, and all of them were super interested. So honestly, I think that's why also we brought this support, or we had this support at the council, because we had already presented the topic and the research proposal to the several regional groups, and all of them were really interested in a follow-up.
Great. Great. Let me just mention, so there are 2 questions we have, or 1 comment, 1 question from people watching. The first is a comment by Eduardo Bertoni, and he says that the overall approach that I was talking about expanding interpretation of provisions rather than talking about drafting new treaties or new protocols seems to make a lot more sense because of how hard it is, obviously, to talk about new treaties and new protocols. He also talked about the importance of paying attention to regional systems, which I think is very, very important as well. And he cites the Inter-American system and the fact that the Inter-American Juridical Committee has already adopted a resolution on this topic, and that there'll be developments at the regional level as well. And of course, the UN system and the regional systems also need to be coordinating and collaborating as well. And there are other regional bodies that are already talking about neurotechnology and human rights, such as the OECD as well. The one question we only had actually 1 question to one question to the panel. How do you assess the right to anonymity, which the person, this is from Katitza Rodriguez from the Electronic Frontiers Foundation. How do you assess the right of anonymity, which she says is well developed in different special procedures and treaty bodies, versus the right of identity? And do you see a tension among both, or can you build upon your right to privacy and identity that you would like to elaborate? So let me see if someone wants to take that question. Maybe Stephanie, do you have any thoughts on that?
I do, and I would like to address that question first by addressing Eduardo's point to the importance of regional systems. One of the big values that we're talking about when we talk about working at the UN level is providing a set of standards that other systems and other organizations can cite to, because the UN just happens to have the largest and most comprehensive body of treaties that could apply to this topic. And I know that in the inter-American system, there are a number of cases before the court and a number of instances at the commission where there are broader citations to the UN authored body of international human rights law. And so we certainly don't at all mean to undermine the importance of regional systems, which absolutely should work in parallel and innovate as they see fit. But this is more just about, in the broader picture, creating a set of standards that everyone can benefit from. To Katitsa's question, and this actually goes to that point of the importance of a regional system, I think there's certainly room to build upon the right of privacy and right of identity, even though there is a very well-developed right of anonymity. And the Inter-American Juridical Committee, which came out with the resolution Jared mentioned, I think actually articulates this point best. They refer to the right of identity in the age of neurotechnology as the conditioning of personality. And that's a concept that's echoed in general comment number 25 on the rights of the child in relation to the digital environment at the UN Committee on the Rights of the Child, which talks about practices that rely on neuromarketing, emotional analytics, immersive advertising, and so on, that should be prohibited from engagement directly or indirectly with children because they affect a child's ability to form and to retain an identity. And so that's certainly an instance where building upon what's already in international human rights law will require some coordination or taking from regional systems to create an overall umbrella concept that applies to everybody. So I hope that was instructive if anyone else would like to jump in.
Yeah, well, unfortunately, I think we're out of time here, and we've done a good job today staying on time. But I definitely want to thank Edgar, Milena, and Stephanie for your important contributions today. I mean, this is the first time we're kind of having these kinds of conversations, as you all have said, and I also find this exceptionally exciting as someone who cares deeply about this field. And we all have a lot of work to do together, and with all of you watching this in the months and years to come, to enable the set of international legal protections be put in place to ensure that while we capitalize on the positive effects and the positive benefits of emerging neurotechnology, we also guard against its misuse and abuse by states and non-state actors. So thank you all for your participation today, and I'll turn it back to Sar, I believe, to bring us through the conclusion.
Hi, Jared. Thank you. Let me introduce Sar. So Sar Lively is a coordinator at the Neuro Rights Foundation, and she has been working very hard to build, in doing all kinds of things, a jack of all trades in a way. But she's built this product that's called NeuroEdge, and she's also performed a market analysis on neurotechnology. And these are important things for all of you to know about. So we've asked her to present her work. So Sar, why don't you take it from here? And the floor is all yours. Yeah.
Thank you, Rafa. 1 second, let me just share my screen. All right, can you all see my screen?
It's sort of small. The images are small. That's better. A little bit larger if you can.
That's the largest that it lets me.
Okay, well that's you can see it. So you go ahead. Yeah.
Okay. Hi. So again, my name is Sar. I work for the Rights Foundation, and thank you everyone again for participating in this really fascinating meeting. So just before we end things, I'm really excited and happy to announce to all of you that the New Rights Foundation has also been working on a magazine, and it's called NeuroEdge. So this is an online magazine, and I first would like to invite all of you that is either curious or really fascinated about neurotechnology and everything that we learned today to go ahead and subscribe to the magazine at neuroage.org. So Neuroage offers, it meant to explore the way that neurotechnology is changing our lives. So basically from culture, business, science to medicine. The idea behind Neuroage was to give access to a wider audience and to give people access to get updates on neuroscience, neurotech, neurorights, and by subscribing, which is completely free as well, you can also benefit from exclusive benefits, such as more conferences like the one we had today, with really the top leading people in neuroscience, and also enjoy our bi-weekly newsletter. 1 second, I think there's a lot of noise, sorry. So sorry about this.
No, it's not bad at all. Don't worry. Yeah.
Okay, so in the future, we also plan on having in the newsletter, we plan on having a curated feed, much more industry reports and educational interviews, product reviews, so much more to come on that. But currently, what we have now is we're going to offer a lot of free access to extensive industry reports created by the Neurorights Foundation. And the latest one that we created is a market analysis on invasive and non-invasive brain-computer interfaces. So the idea behind this market analysis that is also available at neuroage.org is to provide us up-to-date information on the current neurotech market size and growth rates over the next 5 years, as well as really detailed profiles of key players in the BCI industry. So I think that what is good about this analysis is it could be very valuable to individuals who want to learn more about the developing space of BCIs and just this fascinating space of neurotech. And when you read it, you can basically be able to answer questions such as, what are brain-computer interfaces? What is the difference between non-invasive, invasive BCIs? Who are the current leading market players in the BCI market? Who are the key investors, and so on? So if you do want to learn more about neurotech, brain-computer interfaces, feel free to download this for free and subscribe for free at neuroage.org. And we're going to have a lot of more similar things like this on the website in the future. So yeah, I would like to thank everyone who registered and watched this incredible meeting, and have a great rest of your day, and just make sure to follow us on Instagram and social media.
Thank you, Sarah. This looks great. So I have a quick question. In the market analysis, what is the current value of investments in neurotechnology for this year? What was your
so for this year, last year, 2021, it was valued at around 1.52 billion. And this not even including the Brain Initiative.
Mm-hmm. Yeah. And your projection, I think you show a little bit of, that's what we're looking at, the projection upwards. Is that sort of the...
Yes. This is the prediction that, let me make it bigger. The prediction that we expect the market value to be at around almost 4 billion by 2027.
I see. So this is accelerating.
Yes.
Yeah. Anyway, so on that note, let's finish the meeting. And I wanted to highlight that this is a meeting organized talking about funding and money. So this is non-profit, pro bono. Everyone that you heard did this out of the goodness of their heart without getting paid. We did get a little bit of support for the IT from the Chen Foundation, and we thank them dearly. And I also wanted to thank, of course, all the panelists that have been with us in their busy days, offering us their time and their thoughts and their insights, particularly those of you also who are joining us at times that were not very convenient for your schedule. I also like to thank the Neurotechnology Center at Columbia University for being our partners in this. And I wanted also to finally thank Lux Steinberg, who's been running the meeting together with SAR. Thank you, SAR, for all your help. But Lux, if you could maybe turn on your camera briefly so that we can give you a round of applause. There we go. There's Lux. Okay, so thank you, Lux, for your work behind the scenes that has made it all possible. And with that, I just think thank you everyone for attending, and just let you know that this meeting has been broadcast live, and we will put up also the recording of the meeting in our website, so that you can access it, or you can share with other people that may be interested in this. And with that, it was pretty much time to close. It's an exhausting day for some of us. We've been at it non-stop, but I hope that this has been useful, and this will advance the discussion of neurotechnology and the realization that it has this fantastic promise, but at the same time some issues that it would be a good thing to discuss now before they become larger. Anyway, so with that, goodbye everyone, and see you soon at another